And we're back. Maybe we go tonight. They're getting things chilled. Hour 22. They have not pushed back the schedule today. Doesn't mean they won't. We started a little bit later because I don't have as much stuff for tonight. I already said it all last night. A couple things. A couple cool things I found. Howdy. So yeah, they're starting. They're getting things chilled down. Tower vents going. Tank pharma's blowing smoke. This top right is they got helicopters flying around. They refuel the helicopters here on the road to kind of clear the range. Roadblock's still up, so we're moving. We're getting there. But I had a couple things to show. We'll just kind of go through them really quick. We had, they showed us in the video last night, but this is a static image of the static fire of the ship. But it's a nice view of the heat shield, and how it's just like it's shiny, it's smooth. There's not tiles missing everywhere. It's a different looking heat shield than we've seen on past ships. So that guy, and just a side view of it, you can see all the ice falling off as it's firing. And then similarly for the booster, that is at half speed too. I think at least half speed. Full speed was much shorter. But that's gonna be what it looks like when those engines light. It's all water vapor. I mean, there's dust in there. Obviously, it's blowing sand and things. That's there, sand and dirt off the sides. But all of this is all just water vapor. And then the disappearing clouds are all the shock waves making things move. It won't sit there that long normally. It's going to do this for a few seconds, and then it's just the clamps are going to let up. And then, yeah. So that's what we're in for. This is a different view of it. This is real time. Yep, face reveal Jedi. Yep. You hear the, I was trying to make the noise last night. That is the acoustic igniters lighting. And then the second part is the massive wave of pressure coming out. But yeah, I mean, you can flame trench is much better than the little stool thing they used to add. I am doing Jedi. We are doing rocket stuff. We're hoping it was going to launch last night. Hopefully it launches tonight. So last night, this guy here, the quick disconnect arm for the ship. Let's see if they got some other views here. Yeah, so this thing up here on the live view, up here, that there's a pin. Not a little pin. We're talking like a big honking pin that's hydraulically powered. We don't know if it got stuck or if the hydraulics failed or what, but it wouldn't release. And because it wouldn't release, that arm wouldn't have been able to move, which means it would have, A, if it didn't touch the booster as it went up, would have gotten fried, or B, it probably would have touched the ship and the booster as it went up, and it would have been a bad day for everything. So So because that pin didn't release to allow the arm to swing back at liftoff, that's what the last two recycles they had. We got down to like 28 seconds, and they recycled because that's right when the pin's supposed to release. Thank you, Jedi. I appreciate it. No ads for you. So yeah, so that was the last two resets. The first three resets they had were other things that they had seen before. They had seen a sensor trip in the flame in the water deluge system that they've just been having finicky sensors, so they were able to get past that. I think that was two of them, and then there was another, and the very first one was just something they had been doing as well. They'll probably have a software update on the next booster or ship. It's just been taking longer than they expect to push back the lines. So when they push back the lines, before when they're done tanking them, they need to get the propellant out of the lines that are leading up to it. So the bits that go through these things and then through the quick disconnects on the booster, they want to push that propellant back away from it. Otherwise, when big fiery thing comes up, it lights them on fire. So you don't want that. So they push back all the propellant, and it's just taking longer than they were expecting it to push it back. So they'll tweak their timings and get that figured out. It'll probably happen again tonight. One thing I just noticed in this one is you can see these markings on the pavement here. That is where the chopsticks, or where the stands for the booster and the ship, those are the markings telling them where to position it for the chopsticks to be able to pick it up. So just notice that on there. I mentioned it last night, but I had no way to see it, but now it's there. So another cool thing, another video that I thought about showing tonight, that's just the SpaceX stream that's starting in another 45 minutes, was this video. So when you look at this thing, look at its height and everything, they start loading a propellant. It starts getting frosty. The humid air just condenses on the side of the booster and the ship, and it makes its condensation, and it freezes into ice. It's not actually propellant come out. It's just water vapor. But it's very, very cold. So right now it's roomish temperature, or out Texas temperature. And then it gets very, very cold. And physics tells you that when things get very cold, they shrink. So NSF had put together a video here. This is of a wet dress rehearsal on the 11th they did. So this is the ship quick disconnect up higher up. So this is higher up. This is up here, this bit. So above the booster at the bottom of the ship. And what this is going to show is why rockets, they're complicated in general, but another complication that people don't think about. Watch what happens when they start fueling this thing. Mute that. See it going down? The whole shebang is shrinking. So that's detanking, tanking. It's going up and down. They have to take that into account when they build the ship. Now think about it. All of these heat shield tiles on here also have to take that into account. So that's why it's not trivial. It's not like, oh, just plaster the tiles on there. That's fine. The whole substructure underneath them is shrinking when they fill it. And then it's expanding as the fuel is used. And then it shrinks back once it gets into the cold of the space. And then it expands again when it gets in the sun side of the earth. So it's constantly changing because it's a special steel, but it's steel, it's metal. So it's interesting to see how much that thing shrinks. That's probably a few feet shorter once it loads up. but the whole thing moves. I don't think I'd ever seen that on this before. I don't think we've ever. Most people don't have cameras as close to launch sites as we can for this one, but all that cold is just making it shrink. So that was, I thought that was interesting to show. I forgot that they had put that together. Anyway, how are you, Jedi? You pop in every once in a while. Hope things are well. But yeah, so we are on track for a launch in an hour and 15, hopefully. Tower vent's still spitting a little bit, so they're keeping it cool, it looks. We had a little bit of a worry earlier when it just totally stopped, but I think they were just kind of getting things prepped. But tank farm is going crazy. They'll start fueling in. They start fueling at, I think, 38 minutes or 36 minutes before. I think it's 38. We got another 40-ish minutes until they start tanking. But the other thing I had is, so for perspective, this is when I went down there in April of 2 years ago now. So this is an unzoomed picture of old launch mount and booster and how close you get to it on that public road. And we had it up last time where that is. Let me get it again. It's crazy how close that is. So that picture would have been taken right here. Just look in this direction. And you can tell well, you don't see them in this one. You don't see the fuel tanks in this one, but it is the older version of the mount and everything there. But that is that picture. But then from like proximity of the beach, here's beach, not far from the beach. This is a public beach, public road going to the public beach. Can't be there when you're launching, but you got a rocket. You got launch towers sitting there right next to you when you're on the beach. And then it's a little different looking road now, but that's just the public road sitting there parked on the side of it, looking at a rocket or a booster. So yeah, that is a very close launch site to a public road. And you wouldn't know it's there when you're on the beach in South Padre. As Alf enjoying his walk on the beach on South Padre Island, down that direction, you can't see it. It's not visible, but down there, there's a rocket facility. So, good place to be to watch it launch. You got the whole place to hang out and see it. Anyway, now we wait. Trying to see if they got any other views on any other channels to look at other than these four. You can see Hoppy here in the background. Right here, this is the first hop they did with a Raptor engine. They put one engine on this thing, looks like a water tower with legs. And I don't even think it got as high as this tower is. I think it like went up a couple 100 feet and came back down. They actually turned it into a water tower for a little while before they built all their tanks. So, but now it's just sitting in a side of the road. So yeah, here we are again. And we wait. Let's hope they don't bring back a silly celebrity that has no idea what's going on tonight again. Hopefully she has left. There's a bigger view of the top right of there. What's happening? So this is the new launch tower. This is the original one. They don't have to rebuild the tower part of this. They are replacing the entire ship quick disconnect arm. They chopped off the chopsticks. The I don't want to see your face. Howdy's ass. Um, it sits a little lower than this tower. It's the same height tower. They're just going to have to put it's not the same height because it sits a little lower, but the structure of it from the concrete here up is the same. They're just going to have to. They've dug down to build a launch pad a little lower to compensate for it because otherwise they'd have to tear the whole thing down. So, and they're not. That's a waste of money. They're not. SpaceX is not against building stuff and tearing it down very quickly. They've definitely done that. If it's cheaper to build it to make things faster or better at some point for a few months and then tear it down, they'll do it. But obviously, depends on the cost. Um, yeah, much clearer skies. There's a few little high clouds in there. Sounds good. We'll be here for at least an hour and 5 minutes. It's either going to launch and then we'll be here for another hour and a half or so, or it's not. So we'll see. Yeah, you got another hour before we even get to the opening of the launch window. They cannot launch for another hour and 5 minutes. And here's another Alf picture on the dunes southeast east of the tower. um, he didn't care about the rockets at all. He just wanted to run around in the sand. He probably would have run right up to the launch pad and looked at it and been like, it is spherical if he looks up at it, so he might have gotten scared at that point. He went underneath the old launch pad and looked up at the circular rocket butt. He'd probably get scared. Or he'd just turn around and pee on the leg and make it his. So yeah, I don't have a lot more for this one to talk about. We're just kind of waiting. We should get some more views in about see where is he? Thought I had it up. Do I not? Oh yeah. He's starting in a few minutes. So we'll probably get a few extra views there. They're starting a little later than it did last time. They're starting only 30 minutes before the launch, so they're probably not going to show all the extra stuff they did last night. But less people faces, more rockets. Ooh, the vapor's going crazy. It's like pouring over the side of that wall. They've got some weird, not really sure what they are yet, but they've got these angled pipes that vent stuff out. And it was just like it's just pouring out. No idea what they're for. But they become active and do things. But I still got another 30 minutes till they start tanking. 25. These thunderstorms are gone, Alf. You don't have to get upset. You survived. Yeah. Anyway, what to do? What to do? What to do? Thought about doing some nerdy coding stuff, but I don't feel like doing it right now. I don't have enough time. By the time I explained what I was doing, we'd have to get ready to launch. So, come here, boy. Want your ball? You weird dog. Saw a picture of more Cybertrucks last night too. You can see more of them here. You got it's like they're parked all up and down here. This whole wall is Cybertrucks. It looks. That ain't solar panels. That's Cybertrucks. Man, this. I'm gonna pull up the other. Oh, there. That thing is going crazy. Go back to the other one. This one's not as interesting. Oh my god. And of course, it goes back to a face. It's like the whole NASA stream when they launched Artemis 2 and they cut to people filming it on their cell phones as the solid rocket boosters were separating. We're not watching this stream to see your faces, people. We want to see the big shiny thing go in the air. And Alf just wants to sleep. Let's see. By the time I adjust this to be on him, he's going to move. I know it. That's how he works. Because he's a dick like that. You in guard mode, Alf? Yeah. Try anything, any other interesting stuff going on? Anything else? Oh, I didn't mute that tab clearly. Yep, it's starting. It was interesting seeing their plan for the lunar constellation yesterday. It makes sense because they already talk between all of their satellites for Starlink with lasers. So why not just point the lasers a different direction and point them at the moon? And then do the same thing you've got around Earth around the moon, and now you've got communications everywhere. So, and at massively fast speeds, which is what we don't have with the deep space network. It's very slow. The only reason they got a lot of data back during the flight around the moon was they were testing an optical link, aka laser, back to Earth from the service module. So it works. It's just it still doesn't work on the other side of the moon. You still have a blackout over there. So one launch puts a satellite over. Well, you probably do it in one launch. You really need two or three, probably three, ideally, satellites to make it work. Because you got to have one on the very back side of it, and then two on either side, so that you can relay your data to those, which then have sight to Earth. But with the constellation they showed, it's just put the whole ring around it, and then whichever ones have sight to Earth are the ones that you relay the data to get them back. So it would work. If you want a moon base with constant communication, you got to do something like that. And we're getting a decent vent on the tower. Another 20 minutes and we'll start seeing frost. Ooh. Let's see if he's got. Who's that? What is this on the right? Oh, this is an outdoor theater or something that's watching? I don't know. Maybe it's something he's sponsoring. Oh my God. Okay. Less people, more things. Why do you keep pausing? Wind is not as friendly for this angle on the bottom right when it comes to seeing things today. It's definitely more windy. It's not terrible, but it's definitely more because this stuff was not going out as far as it was yesterday. Yesterday it was pretty calm, to be fair. But this stuff's moving pretty far off to the northwest, I think. That's an onshore flow. Let's see. Let's see if I pictured that right in my head or not. What direction is the wind going? Down there. Oh my God, I hate ads. Go away, Allstate. I don't, or SAP. I really don't care about you. Wait, which direction are we looking at? This direction we're looking is like east, almost due east. It's at least going north. When I look at the wind on this, there's not a weather station down there, and that I'm surprised at Starbase. You'd think they'd have a weather station, but all these winds are going southeast. I don't know. Because that camera is looking this direction here. And the going that way, going north. But that ain't the way those are pointing. Who knows? Or it's going. It's either going north or west. It's definitely not going the direction that those wind things are pointing. Well, I guess like that means the wind. Oh, those are right. Never mind. I'm an idiot. I was misreading the thing. So the direction that these are pointing is where it's coming from. So it is coming out of the southeast. Okay. Southeast wind from. Okay. I'm not crazy. Cool. I'm just don't know how to read a map. Roadblock is moved. That is good. Let's see. No. Have they posted any updates? Nope. Have they posted any updates? Starship team is go for prop load. That was 5 minutes ago. Heck yeah. About 20 minutes we'll have their stream, which is right as prop is starting to load. They keep their faces off of it. I can keep this one up. Oh my God. Just as I say it, face pops in. I don't want to see you. But the good thing about that direction of the wind means once it goes up, this angle we're looking at now and anything on the beach that they have is going to be perfectly clear because it's all the exhaust is going to blow out to the left. I mean, there'll be stuff to the right from the pad, but once it gets up, it's all going to be going to the left. So we should have a nice clear view up. Not a cloud in the sky. At least that sky. I feel like these cameras are different exposures. I guess that would have to be true because one is looking toward the sun and one is looking away from the sun. This one is looking away. This one is looking toward, more washed out. See, I told you Doggy wasn't interested in rockets. It puts him to sleep. All right. Well, hopefully Mr. Pin works today and we get a launch. I feel like everybody was itching to go yesterday and the ground equipment just wouldn't cooperate. Wish they changed that top left view because it's kind of pointless now. Let's see if who else is running, if anything else is of interest. Oh, I thought I heard a tornado siren. I just heard a fire truck, which is also not great, but it's okay, Alf. I heard it before you. Mm-hmm. You were passed out, bud. Here's a different. Just no, I don't want your chat. Yeah, there you got some times on there that I don't have. So 7 minutes until they start locks on the ship. Almost 11 until the booster. And then methane on booster and ship start pretty close to each other. And the reason for that order, I don't entirely know the reason for the first two, why it's ship and then booster, because the booster needs so much more. But probably because it's got bigger holes, bigger plumbing. But the reason they do locks before methane is because there's more locks than there is methane. There's about, for every, we'll just say, pound of methane on board, there's like 3.6 pounds of locks, liquid oxygen. So it's just the way they combust, and that's the most efficient ratio, at least for Raptor engines, to combust. So always more oxygen than methane. Oxygen is your oxidizer, methane is your fuel. You can technically, I think, do 3-to-1, but they do 3.6-to-1 because it's a fuel rich engine. It's optimized to have a little bit more methane than it needs. A little more zoomed out view from him. The Highway 4 is right here, the road, and this is all. The plan, I believe, is to make this road much larger so they don't have to block traffic every time they roll a rocket. They can just go around it. But they also had to put in, because I mean, there's no reason to have a crap ton of power and water and things going out and utilities going out to the beach. Had to add all that stuff in there. That's all these poles for marking off where all the utilities are. When they did their first launch, they didn't have power running from the main grid out to the launch site. It was all run off of generators. And then when things went the way they did, when they dug their hole, they caused a lot of havoc in their infrastructure out there with pieces of concrete flying in things. Alf, stop. Hold, please. He's going crazy. All right. He's decided to really not like the Amazon delivery truck today. Not even for us. Just drove past in all of his electric glory. All right, let's see. We're still on track for 5:58. Yep. 8 minutes. But they're going to start loading prop here. Why? Why are you paused? Oh, their stream is kaput? Yep, it crashed. This one's still up, though. And that's what they get for playing with their setup. Every time you make changes to something, it breaks something. So they should be into LOX load on the ship at this point. Let's see. They're still broken. He's looking at the booster. Pull this one over. This is the ship, so we should start seeing frost. Well, the tower vent's still going, so they haven't actually started loading. That tower vent has to stop before LOX is loaded. I thought it was at 36. Anyway, I was like 36, 30, or 20. I feel like his times on whoever this is, I say he, but I don't know who this is. Their times are off. And we wait. It will stop eventually. Oh, it's petering out. Maybe, or maybe not. Oh, there it is. 36:30. See, I knew it wasn't 38 minutes. This guy's got a PTZ camera. PTZ equal point tilt zoom. These lines are not quite frosty yet, but that doesn't mean stuff's not going through them yet. This is not a great camera, not a very stabilized camera. This would be like if I was there doing this. No, I would, if I was doing this for a living, I'd be getting some nice cameras. See what we can see on his. Normally he'll, oh, just kind of spitting here and there. It's not like it's full flow anymore. You'll start seeing discoloration on there. Basically, it'll start turning a darker gray. Have they fixed their crap yet, or are they still kaput? Oh, there they fixed their stuff. Hang on. Okay, I'm muted on the tab too. Good. That's probably why it keeps pausing, because if you mute YouTube and then go off the tab, it thinks you stop watching it. You're starting to see a little bit of stuff coming off of the quick disconnect now, on that view at least. I don't know what, oh, this is not live. There we go. Yeah, there you go. So now you can see those lines are chill because they are, there's some vapor coming off them. And then we should see in here, it will start discoloring. It'll get dark and then it'll start getting white pretty quick. And you can kind of, this picture is terrible, but you can see why the tiles look different. That's a horrible, horrible, horrible view. See, any of those are better. No. But there's the normal size tiles there, and then there's a different pattern looking here. It's because this is where they have their stringers, and this is the bottom of the tank, of the oxygen, liquid oxygen tank. And then below that's all the engine stuff, the engine skirt and everything. So they have to put tiles on it slightly differently. That was a big part of what they were figuring out in those first few flights, was how to make them stay on these weird places. So come on, Frosty line. Yeah, it says it's underway. That's what they're saying. Yep. Why didn't my feed refresh? Yeah, underway 2 minutes ago. There you go. I get live. So there's that. The frost is growing now. So you get frosty, and then above it you'll see a discoloration a little bit, and then it'll eventually turn frosty. And this is just going to keep climbing up the side of it. But even just watching it, it's doubled in size in that time. It's crazy how much propellant is loaded on this ship and booster in the time that it takes to load it. I told you could sit here and watch it grow. And it's not like other loading where it's and just it creeps up millimeter at a time. This thing is just flying how fast it goes in there. Let's see if these guys zoomed in on things yet anywhere. 558. All right, there they go. Nobody has zoomed in on the ship. I don't understand why. I feel like their production stuff died because this is a single view. And those, well, they changed it. There were two vehicles down there that I don't know if you noticed it. Those are not manned vehicles. Those are unmanned camera vehicles. You can start seeing the frost there. You can see a little bit maybe down here on the bottom of the booster already. So I didn't hit live and just went back. When I hit live, it grew. And you got the SpaceX thing up there now too. And you can see, is that methane frost there? It looks like there's a methane frost up here. So there's the little stringers for reinforcements between the methane and oxygen common dome there. So there's methane getting loaded up there too. So, all right, we'll go back to official stream coverage.
All right, all operators on the count of 1. Flight directors go for launch. Stage separation. Booster light burn center. Booster has landed. Stall to the transponder.
Hello once again, Star People, and welcome back to Starbase Texas.
Star People.
It's currently 5:01
We're not in the stars
PM
yet.
Central
I mean, I guess we
Time,
technically
and
are.
we are just 28 and a half minutes away from the first flight of SpaceX's next generation vehicle, Starship version 3. Yesterday's launch attempt was scrubbed due to a hydraulic pin on the pad tower that wouldn't retract. But good news, the teams were able to resolve that issue, and we're proceeding ahead with attempt number 2 and blue skies to boot. I'm Kate Tice, Senior Manager of Quality Systems Engineering.
And I'm Jake Berkowitz, a lead propulsion engineer. And today we're coming to you live once again from just outside the production floor at Star Factory, where the team's preparing for Starship's 12th test flight.
Yeah, yesterday was certainly a
Say hi,
nail-biter
boy.
as we recycled to the T-minus 40 second hold a couple of times. And while we unfortunately
bored,
weren't
aren't
able
you?
to lift off, keep in mind that this is the first flight of a completely redesigned vehicle. So we actually learned a lot in what became a wet dress rehearsal yesterday.
Yeah, that's right. And Starship version 3 has undergone significant upgrades, taking everything we've learned from the previous 11 flights to make a vehicle capable of
resolution.
full and rapid reusability.
We're
No
debuting
auto.
a new launch pad, new booster, new ship, and new engines, just to name a few.
Yeah, that's right. And as a member of the Raptor team, I can tell you we're all super excited to finally see the newest generation of Raptor engines, also V3, take flight today.
I love that view looking up under the Super Heavy. Now, Raptor and Starship version 3 are designed to enable us to send payloads and eventually people all the way to the moon and Mars.
Yeah, and in the meantime, we're planning to put Starship to work on future flights by launching bigger and more powerful Starlink version 3 satellites, which aim to substantially increase capacity in orbit, strengthen the network, and deliver an improved experience for customers.
Now, turning our attention back to today, our primary objective for Flight 12 is to put these new redesigns all together in a real live flight environment. From the outside, a lot might look familiar on Starship, but beneath the surface, it's all new. As we've said before, Starship is still a developmental program. What we're doing today is a test. We launch to learn, and we test like we fly.
Yeah, and it's really the data we're expecting to get back from today's flight that will bring us closer to making Starship operational and unlocking the next generation of our future in space. So, no matter the outcome of today's test flight, excitement is guaranteed.
Now let's head a couple floors upstairs where Dan Hewitt is just outside our Launch Control Center. How's it going up there today, Dan?
It's going great, Kate. Everybody, welcome back for round 2. I'm Dan Hewitt with SpaceX Communications. We're looking good for a launch today. Do you want to do a quick summary, though, of what we saw yesterday, how we got back to launch? It's a really good example of all of the different moving parts that have to work together to get a rocket off the pad. About halfway up that tower, you see an arm that holds all of the propellant connections into the ship. It's also set up so it kind of pushes against the ship to help make sure that we have a really good connection and it stays attached when we unlatch that that quick disconnect. There's a pin in the arm near where that attaches to the tower that has to be removed before the arm can swing away for launch. It's important to remember there's a lot of benefit to not release the arm too early or too late, and a lot of hardware that has to work in concert in very, very short time frames. We started to unpin it. Releasing that tension caused some motion in the arm that triggered a hold, and that put the pin back in. Then that got us into a bit of a tug of war between systems on the tower that rely on hydraulic pressure to work. Really, the arm trying to keep its pressure on the ship and trying to pull that pin out. You saw we made a couple of attempts to fix the issue, eventually got the pin to start retracting again, but hit the same motion hold. Ultimately ran out of time. The team, though, made some hardware, some software changes to get us into a better position to fly today. We had the tower team up there last night. They welded in some hardware that's going to cut down on the motion of the arm as it's pushing back when the pin's released. And getting all the data we saw on how this hardware interacts in those critical moments, went in, looked at our software, all of our logic, see where we were overly conservative, where we may have had holds built on the wrong readings or the wrong times. Overall, though, really fast work by the engineering teams put us in a position for flight today. Heroic work by our logistics teams to get all the propellant out there. But things are looking really good for launch at the moment. Right behind me, all of the flight controllers
after being connected to the
console,
ship.
looking at the
They
rocket,
have
looking
yet
at
to
the
do
pad,
that.
looking at the range, all the systems as we count down to liftoff. Propellant load is underway. You can see the rocket getting frosty. We're on track to launch at the top of our window at 5:30 p.m. Central Time. Weather has been gorgeous. Thank you to everybody who was outside yelling at clouds that got us weather yesterday. It extended into today, and we are looking at a green range right now. Functionally, today's countdown, identical to yesterday, looks very similar to previous Starship flight tests. Some minor differences in timing on things like when we start propellant load, when the water starts flowing on the diverter, when our engines start up. But all the hardware is new booster, new ship, new engines, new pad. Let's do another quick look at everything that's debuting today with Starship version 3. As Kate noted, some of the outside will look familiar, but we've made extensive upgrades across the entire system. Big picture, because Starship's still very, very big. It's just over 407 feet tall, fully stacked, a little bit taller than version 2, have more propellant in both stages. On the bottom half, our super heavy booster has some visible structural changes on the outside. On its top, we've got an integrated hot stage now, got rid of the one-time use one, so we're doing that for reusability. The ship's Raptor engines are going to be igniting directly into the top of the booster. That's where you're looking right now. All of that force and heat offset by the pressure inside the booster's fuel tank and a thin layer of non-structural steel. The grid fins on the booster, which we used to steer on descent, went from 4 down to 3, but we made them 50% larger. Higher strength, also use them for lift, and we'll use them for catch on future missions when we bring the booster back. We redesigned the fuel transfer tube inside the booster. That's what's sending all of that massive amount of liquid methane down to those 33 engines. Lets us light all 33 at the same time and have faster, more reliable flips. The bottom of the booster looks very different with those Raptor 3 engines. We deleted all of the bulky engine shrouds from previous generations, all of the prop, avionics hardware, everything for that super tightly integrated now, protected by much slimmer shielding. Up on the second stage, Starship version 3 designed to carry massive orbital payloads up to 100 metric tons to Earth orbit, the Moon, and Mars. Biggest changes inside the vehicle itself. Propulsion system got a complete redesign, increased our propellant take volume, improved our steering on orbit. In the payload bay, the PEZ dispenser is supercharged. That's going to increase the deploy speed for each of our satellites. We've got 22 payload deployables in there today. It's the heaviest we've ever carried on Starship. Eventually, we'll have up to 60 planned of those Starlink V3 satellites. Also on the ship, we added docking ports. There's 2 right below the payload bay door, 2 near the bottom. That's going to enable us to have starships link up in orbit for propellant transfer. Also modified the connection point in the ship to facilitate that. So a lot of upgrades tip to tail, and still powering it all is the Raptor 3. Now, those engines are manufactured in Hawthorne, California, tested in McGregor, Texas, redesigned their ignition system, bumped up the thrust in the sea level and the vacuum engines, and then took all of the sensors, feed lines, controllers, everything that was kind of the busy sections around Raptors 1 and 2, and either deleted them or internally integrated and protected them inside the engine. That dramatically cut down on the weight, made it easier for those to manufacture. So, Just an incredible amount of effort from the world's best engineering team getting this rocket to the pad ready to launch today. I'm going to stop talking for a little bit. That was a lot. Send it back down to Kate and Jake for more on Pad 2.
Yeah, so like Dan was just saying, the team has been working hard on a brand new rocket, but we also redesigned the ground systems. And that brand new Pad 2 is making its debut today.
We took everything we learned from operating on Pad 1 to create this totally new launch pad. Pad 2 is optimized for full and rapid reusability. We've upgraded our propellant farm with much more storage and more pumps to enable super fast filling for launch and relaunch. And on the tower, we changed to shorter chopsticks. That's the black assembly there at the top of the tower, and that enables even faster motion to better track vehicles flying in for catch.
Yeah, and we also changed the actuators driving those chopsticks from hydraulics to 100% electromechanical, increasing their speed, redundancy, and reliability. On the ground, the launch mount was also completely redesigned, and if I had to describe it in one word, I'd say robust. But it's also smarter. We've separated the fuel and aux systems into different compartments and repositioned the booster quick disconnects to be out of the vehicle's plume during liftoff.
And as you can see there on your screen, we also have a new bidirectional flame diverter and a new top deck flame deflector to eliminate metal wearing down. So we said goodbye to the pancake. However, this will help us get to zero refurbishment between launches. Now this pad is still built for maximum safety and fast turnaround because making life multiplanetary will require launching a lot of Starships. Now, it's currently T-minus 18 minutes and 38 seconds. We're going to hop over to Hawthorne for a moment for more on Starlink with Tyler Lionquist. Tyler?
Hey, Kate, thank you so much. I'm Tyler Lionquist, and I'm a Starlink business analyst here at SpaceX. We're excited to be back here in Hawthorne, ready for another attempt at a launch today. So as we talked about yesterday, on today's flight, we're deploying 20 Starlink simulators, plus 2 modified Starlink satellites, which our team internally refers to as Dodger Dogs, because they stretch the V2 Mini satellite propellant tank so that it sticks out from both ends of the satellite. And the Dodger Dog serves as a tech demo between the V2 and the V3 Starlink satellites, and acts as a platform for testing V3 components. Now, the larger V3 satellites aim to greatly expand our network's capacity, while V3 hardware is designed to support faster Wi-Fi and improved broadband speeds for our customers while providing significant capacity upgrades from the V2 Mini. So, in addition to delivering future V3 satellites to the Starlink network, Starship is also planned to launch our AI satellites. And as you may have seen during the TerraFab event in Austin a few months ago, Elon laid out the path to revolutionize cloud computing and AI infrastructure, leveraging the unlimited power of the sun, targeting 100 gigawatts to 1 terawatt of AI computing power annually. And from there, we're looking at connectivity beyond our planet too. Building on the technologies used to connect people on Earth, the Starlink team is exploring using Starlink to enable high bandwidth connectivity around the moon. With a constellation of satellites designed to connect to user terminals on the lunar surface, we could relay data back to our Starlink constellation in Earth orbit. So traditionally, deep space comms have relied on radio frequency transmission. But this new design would use lasers to relay data back to Earth, which can massively increase the bandwidth available to future lunar missions. We currently have thousands of lasers operating in our Starlink constellation around Earth, and deploying that technology around the moon could connect it with hundreds of terabits of capacity. Together, this could provide the connectivity backbone between the Earth and the moon, and enable gigabit connectivity anywhere on the lunar surface, providing data for rovers, habitats, and astronauts, and hopefully some incredible views for us back on Earth too. So all of that adds up to a lot of satellites. But the good news is there's still plenty of
my
space
Starlink
in space.
options.
That said, the Starlink team takes space safety
Wonder how much it
extremely
costs a
seriously
month.
and works hard to encourage best practices across the entire industry so space stays open for as many people as possible. In fact, just yesterday, the Starlink team published a new update on Starlink.com to encourage all satellite operators to better coordinate and follow best practices to keep space safe. So for more on safety, go to starlink.com/updates. And with that, let's kick it back over to Kate and Jake and Starbase for today's mission profile. Thanks, Tyler. Now let's dive into the flight profile for today's test. As we've mentioned already, a couple of times. There are numerous redesigns making their debut today across the entire launch vehicle. In light of this, we want to keep our learning focused on all of that new hardware and software. So we're running a flight profile that's similar to past Starship flights in order to minimize any new variables.
Yeah, that's right. So as always, we start with liftoff, where Super Heavy ignites 33 of those brand new Raptor 3 engines. We power through ascent ahead of hot stage separation, where the booster shuts down all but 5 sustainer engines. Stage 2 then lights its Raptor engines while still attached to Super Heavy, where we see stage separation, debuting the integrated hot stage, directional booster flip, and engine relight for boost back using 33 engines. And after coasting for a few minutes, the booster today will target a landing burn and soft splashdown a few miles off from the coast to Starbase.
Ship keeps it going with ascent burn to a suborbital trajectory. Then we'll deploy 20 Starlink simulator satellites and 2 Dodger dogs, as we affectionately call them. We
just
also plan to
noticed their
relight a single Raptor engine.
animation was
Next
2
will be
hot dogs
re-entry
coming out
a
at
few
the end
minutes
there.
later. For the first time in a while, we're intentionally not messing with Starship's heat shield. At that point, we should have some amazing views of the ship's Technicolor re-entry through Earth's atmosphere. If all of that goes as planned, we'll finish the test with a landing flip, a landing burn, and a soft water splashdown in the Indian Ocean. And in just a few moments, thanks to Starlink, we'll be going live to the Indian Ocean and chatting once again with the ship recovery team stationed out there.
Yeah, I'm super excited about that. That's going to be
Hopefully
totally
they
awesome.
repositioned the
But sit
Starlink
tight,
terminal
because
this time.
First, we're going to go to Dan for a quick status check.
Yep. Hey, everybody. Good news. Still looking good. Range is green currently. We're expecting another update on that in just about 4 minutes. That should be our final determination. Weather continues to look amazing. Vehicle and pad both looking healthy. We are a little over 80% on fuel, 95 on LOX in the ship, and then a little more than 2/3 it's looking like on booster. So we are on track today, looking good for a launch right now at 5:30 p.m. Central Time. All right, so we're going to do that right at the top of our window. Once again, though, we're going to be targeting to send Starship around the world for a splashdown in the Indian Ocean. We had a really quick check-in yesterday with the Starship recovery team out there on station. They're helping us to maintain the range and a whole lot more. So let's jump back out there once more today. We've got Suren Sunai joining us live from the boat deck out in the Indian Ocean, a couple hundred miles off the coast of Australia. Suren, how's it going, man? Welcome to the Flight 12 webcast. How's everything looking out there in the landing zone?
Dark.
Dan, it's a pleasure to be here. I'm not going to lie to you, it's a little rougher than it was yesterday. Nighttime, it's hard to see the horizon, but we're looking at about 10-foot seas, and we're loving it, but it's rough.
All right, what's your guys' primary job out there? I mean, you're out kind of in the middle of nowhere. What are you guys doing?
So, like as you mentioned, like it's usually a 500 to 600 nautical mile sail from shore. And our primary goal is as a range clearing group. So like we come out here and make sure there's no one else in the area so the rocket can launch. But that kind of allows us to do our second goal, which is to conduct imagery of the rocket as it re-enters and as it splashes down. We get a lot of other data, but like the primary one is for sure imagery with an ensemble of maritime and aerial-based assets.
And talk to us a little bit, because it's evolved over time, kind of humble beginnings of getting those views, to talk us through where we've gotten to now today.
Yeah, I think some people know, but like the Markset bots are quite identifiable. That's the buoys that we use. And they were originally used as sailboat racers. And we kind of put them in as a Hail Mary attempt on Flight 5 to get imagery of the rocket as it came down. And we all thought it maybe would have worked, but we were super shocked and really pleased to see all of the buoys pointed right at the rocket as it came down, which was a testament to not only the scrappy engineering we were able to put together, but also the rocket's ability to land right on target. And then since then, we've kind of iterated more and more, and these buoys have become way more robust and have now a lot more data collection materials, not just visual imagery. And as a result, they kind of are the most mature versions they've ever been. And it's really cool because almost all the buoys that we're deploying even now for Flight 12, we just got them off our back deck a few hours ago, are the exact same ones that were used for Flight 5.
And I saw a couple of user terminals. How's Starlink kind of playing a role in this entire operation?
Dan, I'm not gonna lie to you. If we didn't have Starlink out here, we would be screwed. Like just on like a usual basis of like working, we're allowed to like have calls with each other and like work on documents with each other, send things to each other in like a very timely manner because of the Starlink on the boat. But not only that, each one of these buoys is equipped with a standard Starlink Mini, the one you would just get from like ordering it commercially, and that allows us to not only operate the buoy remotely, but also to get live stream data and telemetry, which is honestly super useful, and I don't think we have another solution for it without Starlink.
All right, before I let you go, what's it like? You're out there, and then all of a sudden, Starship appears out of the sky. What's that feel like, man?
Dan, I can't lie to you. It feels awesome. Just like being on the boat, not seeing any land for miles and miles, and then hearing the Starship crack down with its sonic booms and watching it breach through the sky. It is one of the most magical feelings on Earth, and really excited to feel that again today.
All right, well, thanks, Suren. Good luck, man. Hopefully we're sending a rocket your way real soon. Thanks for joining us in, man. I'm going to send it now
Slightly
back down
a little
to
bit
Kate
offset,
and Jake,
hopefully.
the latest progress we're
Not
making at
directly
Cape
at 'em.
Canaveral in Florida.
Thanks, Dan. Now, if we want to get to the moon and then Mars as fast as possible, there's really only one answer, and it's to launch a lot more rockets.
Yeah, and to do that, we're going to need a few more launch pads and support buildings, which is exactly what we're working on over in Florida. So originally built for Apollo and then the Space Shuttle, Launch Complex 39A has flown 126 Falcon missions since SpaceX reactivated the pad in 2017.
Yeah, I actually remember the day that we did that. I was able to host the live webcast for that first launch out of Pad 39A, and it was just so amazing to see that pad come back to life. And it's also exciting to see how today, almost 10 years later, the ongoing construction, as you see there on your screen, and the development that will bring a second launch tower to Launch Complex 39A. It's designed to expand our capabilities to support Starship launches in the future, while also continuing to support Falcon Heavy missions from the original Apollo Shuttle Falcon launch tower.
Yeah, and we're not done. We're also building a Starship launch pad at Slick 37. And to support the uptick in future launches, there's Gigabay, a giant assembly and maintenance facility designed to prep Starships ahead of Florida launches. And when complete, this huge structure aims to hold 24 work cells in over 800,000 square feet of workspace. It's going to be a big building.
So much space.
So yeah, SpaceX's future in Florida is quickly taking shape with our very first launches on the horizon.
Exactly. A horizon that aims for regular trips to the moon. And speaking of moon, we've got another special guest for you today. Dan, I think the last time you and I were on a webcast with this person was Polaris Dawn, as he was performing the very first commercial spacewalk.
That's
Hey,
right,
Jared.
Kate and Jared, I don't know if today will be quite as cool as doing a spacewalk, but we're going to try our best to make it as exciting. Like, thanks for joining us here
He
today,
flew
man. You
some
had a heck of
NASA
an entrance on the
employees
way
over
out.
the launch
It's
site
great to be
earlier.
here. Yep, certainly
in the
great to do a
jets
little bit of
as
a flyby. I think they should
rewards
accompany
for
all
doing
the
good
great rocket
stuff.
launches, and we certainly got a great rocket out there on the pad. But wonderful to be back, and no surprise, it's always changing here. It looks amazing.
I was going to say, it's been a couple of years. What was your impression flying in? It just the lay of the land.
Well, I think it was actually maybe 10 months ago. I was here slinging pizzas. I got a new job now, but it was. There's been so much that's changed even since then. Yeah, the facilities look amazing. All the housing that's coming in here, and of course, you got 2 orbital launch pads out there and a rocket that's just looking fantastic, especially from the air. It's good.
Yeah, you said you got a new job. It's been a slow start to your first 6 months. I mean, you only sent humans around the moon for the first time since the Apollo days. Bill and I kind of nerded out a little bit. Like, that was the last thing I worked on when I was at NASA, so seeing them go was just insane. Like, how's everybody feeling after the success of Artemis 2?
Well, I'd say I have the best job in the world, and I certainly work with an unbelievable team. I mean, as you know, that mission was a long time in the making, so I got to show up at the right time to see everybody put all that effort to put it in action. But what a great mission. Those 4 astronauts, you couldn't have had better ambassadors for humankind to the stars. I mean, they really brought us all along for 10 days, and we're getting ready for what comes next. We're going to start stacking Artemis 3. We got a lot of the hardware in the VAB already. We're hoping to even get out to the pad before the end of the year, do another wet dress. So,
all right.
And we're looking forward to seeing this thing fly, because hopefully at some point in the not too distant future, we're gonna join up in Earth orbit.
Yeah, I mean, what's coming up next, and ultimately, like, based on the moon, that's the big focus. Like, what's kind of the why? Like, why are we doing this for everybody?
Oh, well, I mean, and yes, we're certainly trying to get back to the moon, but what's coming up next? We're also building a moon base in parallel. And why are we doing that? Well, it's for a lot of the shirts I see around here, which is Occupy Mars. I mean, what a great opportunity. Go to the moon, return to the moon, build a moon base on the South Pole, interact with the water ice, right? Maybe work on some of those skills we're going to need when we're 4 days away from home for what we might need someday when we're 9 months away from home. But we got other things coming up too. You got Nancy Grace Roman, that telescope's going to launch later this summer. There's a lot of great, exciting things going on at NASA right now.
Yeah, man. All right. Well, SpaceX, we're custom built to try and make life multiplanetary. We're super honored, excited to be part of this entire Artemis program. Really excited to see Starship, sending people to the moon, all of the different pieces working together. It's going to be a really exciting future.
Oh, absolutely. Well, thanks for having me here. It's great to see everybody. Again, I know a lot of hard work leads up to a moment like this, so we're all rooting for you, and we're looking forward to meeting up next year in Earth orbit.
All right, man. Well, I'll let you jump back in there. Got about 4 minutes to go. I'll just toss it back down to Kate and Jake.
Yeah, I think it's safe to say we could listen to you guys
So much
yap
better
about
than
the
Nicki
moon pretty
Minaj.
much all day. It's so inspiring to hear about the future of exploration on the moon. And if you caught the show yesterday, you also heard some more future space exploration news.
Yeah, that's right. From to Mission Commander Chun Wang will be one of the first humans to become an interplanetary traveler. Don't think I've ever said that word before. While also joining Starship's first mission to fly past the moon.
Yeah.
Incredible.
Amazing. In fact, that Dragon capsule that you saw there was Dragon Resilience. That is the same Dragon spacecraft that Administrator Isaacman flew in both Inspiration 4 and Polaris Dawn. So it's a good one. Now, Dan, we're now coming back into a terminal count again. Anticipation is definitely growing as we proceed towards our second attempt. Once again, this is the first flight. We're aiming to fly for the first time, Starship version 3. Massive upgrades across the vehicle that you see at the pad there, as well as the pad itself.
The good news is we've had a pretty quiet countdown today. We are looking at a green range still, not tracking
It's just
any
boring
issues
rocket
with
stuff.
our weather, with the vehicle, or with the pad for a launch. We are now getting into the phase where we're closing out prop load on the ship, and then booster is going to close out in about 15 seconds or so. Once we're fully done with this, you're looking at 11.5 million plus pounds of liquid propellant on board Starship and Super Heavy. We're going to get the pad itself ready, push back all of the propellant that's in those lines running from the farm up to the launch mount, just kind of harden the area and get it ready for launch. We're going to peek inside, hopefully see the engines do a little wiggle as we do our final steering check. That'll happen at T-minus 100 seconds, and then after we get through T-minus 40. If you tuned in yesterday, you're very familiar. If we need to hold, we can go into what's called rapid recycle, essentially, where we can hang out at T-minus 40 seconds. It's built in. We're only going to hold if there's an issue, not currently tracking one. They can pop up after we pass T-minus 40, but right now we're looking good. Hopefully going to move right past that.
And then once we do pass T-minus 40 seconds, a number of events will occur in quick succession. That is when the QD vent gate, or quick disconnect vent gate, will clear the gas commodity lines that connect the pad to the vehicles. Both the ship and the booster will configure their comm systems for flight and will rapidly run leak checks on gas and fluid tanks. And the booster goes to internal power, and its engines will get their final priming for launch, while the ship's engines begin their ascent bleed profile and arms the automatic flight safety system.
Yeah, and once we pass T-minus 40 seconds, we still have the ability to rapidly recycle the count under certain conditions back to T-minus 40 seconds.
Looks like we might be getting some engine wiggles here, as Dan mentioned earlier.
Oh, yes.
These allow us to check out the thrust vector control
Do it.
actuators on these engines. It's important to make sure that they can steer.
Yeah, that's definitely right. And flame diverter on pad 2 activates at around T-minus 17 seconds and enters what is essentially the point of no return at T-minus 10 seconds. If we have a hold close to T-minus 17 seconds, there's a chance we could recycle, but the closer we get to T-minus 10, the lower that chance becomes. We just heard we're at T-minus 1 minute.
Yeah, so at this point in time, we're going to stop talking. We're going to let the rocket take over and listen to some amazing pad sounds of the first flight of Starship version 3.
All right, we are holding. We were just waiting for the fuel pushbacks to complete into the prop farm. We did hear that that did just complete, so expecting them to reset that hold shortly. Clock, the hold is reset, clock is rolling.
God can move.
Flight directors go for launch.
Further than I got yesterday. There goes the deluge.
Minus 10, 9, 8, 7,
Ooh,
6,
the top deck goes early.
5, 4, 3, ignition.
Yes, go!
Liftoff.
Woo!
Pitching downrange.
Yes. That thing got off way faster than the V2.
Booster Raptor, chamber pressure nominal.
All right, we are T plus 30 seconds into flight, seeing 33 out of 33 Raptor 3 engines on booster V3, ascending over the Gulf now, coming up on maximum aerodynamic pressure.
Booster and ship, avionics power, telemetry nominal.
Systems looking good. We're just passing through the period of maximum dynamic pressure. A little over a minute into flight now. Vibrations chilling out here at Star Factory as we continue to watch Starship Flight 12 arc out over the Gulf. The next major thing coming up is going to be hot staging.
Booster prop systems nominal.
Reminder, we do what's our version of MECO. Most engines
That
cut off,
view.
so we're going to shut down all but 5 of the Raptor engines on the booster. And then after that happens, we're going to ignite the 6 engines on ship while it is still attached. We have clamps that hold the 2 together. Those are going to retract inside of that hot stage ring, kind of protect them. Looks like we had 1 of the engines go out, still flying on 32 of the Raptor engines. But again, once we get the hot staging, those 6 engines on the ship are going to ignite. We're going to do it in a little bit different of a sequence on version 3. Essentially, those 3 RVAC engines will ignite first. Almost immediately after, just 1 of those central engines is going to ignite, and that's going to give the booster a bit of a kick, sending it in a known direction, followed shortly after by the other 2.
Down to 5.
We're through MECO.
Need separation.
Video is delayed from telemetry, just FYI. Hey. Yes.
There you go. Successful hot staging separation.
Interesting
We're
relight.
not seeing as many booster engines ignite.
Yeah, the
as we
booster doesn't
expected
seem
for
like it's in a good,
boostback,
happy place. That's
but we are
probably going to
seeing
get
6
blowed
good
up here in a
engines
second.
lit on ship. It looks like we just had an early boostback shutdown. Again, a reminder, the booster was planned to essentially head into the Gulf for a splashdown, but it has shut its engines down early on into boostback.
Yeah. What was that?
And we just
Oh, we lost an
see
engine
one of
in the ship.
RVAC, so we're now
Ain't
running
going
on 5
so
engines
well.
on ship. We do have engine out capability, so it's going to continue into its ascent. You got booster on the left there, ship on the right.
Ship, avionics power,
Again,
and
we are
telemetry
not
nominal.
planning on bringing the booster back for this flight, as this was the very first time.
The shadow, you mean down here? This thing? That's the exhaust plume
All right, so
on
about
the
3
Gulf.
minutes, 50 seconds into today's flight. Just a reminder that the ship planned to burn its engines for about 8 minutes and change.
Sun's off to the west, so
about
it's
8 minutes and 11
shooting it
seconds
back
is our
east, the
planned
shadow.
timeline for today. That could shift slightly as we do have one engine out, running on one fewer RVACs.
Well, I was hoping to be more perfect than that, but
Again,
it got off the
continuing to
pad.
watch. The booster did not complete its boost back burn. We did not see all of the engines ignite that we expected. Are continuing to get some views from it, though. That's going to make a splashdown somewhere in the Gulf. Reminder, we clear air, sea space, everything for these launches.
Well, they got data at least from both of these, worst case.
All right, so we are coming up on T plus 5 minutes.
Still comms. We got video from both, so they're
Ship
not like
continuing to fire 5
burning to
6.
death.
Standing by for
The
call
ship
outs,
can still
making sure
finish it
ship's
though, because
on
it's
its
not going to
planned
use those
trajectory.
RVACs
Again,
after
we
this
are
initial
planning a
ascent. It
suborbital
only needs those center
trajectory for the
three.
ship
So
today. Booster giving us some views as
Hey, look,
it
the
continues
Earth
to
rounds.
make its way back down towards the water. All right, so a little over 5.5 minutes in flight. Kate, Jake, you guys with me? It looks like booster's starting to come in hot.
Yeah, we had the opportunity to stand outside to watch launch, and wow, that was incredible.
Yeah, that was really loud, really shaky, and I was actually surprised how fast the
With those
booster got off the
clouds
pad, or the whole stack. That was
coming
that
up
was
to
quite
it.
incredible.
Absolutely. So we have views here from the
it's
booster.
not intended
coming
to take
back
this
down,
type of
making its way
trajectory,
into
so it
the Gulf.
may just abruptly end
Pretty
its
cool to
flight.
see.
Healthy chamber pressures on 5 out of 6 ship Raptor engines.
Great news there
Landing
for
startup.
Starship.
Hey, I got engine startup on the booster somehow. To slow it? Is it actually going to
Once
land?
again, we were not going to bring the super heavy booster
Oh,
back
booster's
to the
gone.
tower. We were planning on having it land in the Gulf.
And it looks like the booster ended its mission there in the Gulf, but we've got a ship still flying. Great to see that. Still have 5 out of 6 engines there on S39.
Yes, we also heard good chamber pressures as well on those engines that are lit. We do have engine out capability. We do see that we have one of the RVAC, one of the Raptor vacuum engines that is currently out, but that's okay. Ship is continuing on. Amazing views.
I'm curious to see a video from the
Yeah, I love the S39
engines
decal there.
on
That
this
gives
to
the-
see what
gives the ship
happened
a
to that
little bit of
RVAC, because that
character.
was
And again, all these great views brought to you
energetic
by
end to
Starlink,
that, because
of
that was a
course.
big old orange thing that happened.
Yeah,
Clearly didn't take out the other
to entire
5, but
Starship Avionics camera electronics team did a whole lot of work to get these upgraded cameras.
there we go.
A look inside of the ship.
So,
you can see those 3 center engines.
this
ignited,
one
the
is
RVACs
out.
continuing to fire as well. We did see at least a couple engines fire up on booster for that landing burn before we lost contact
think.
with it.
I can't
We
tell.
should have just a little over 20 seconds to go. We'll see if the burn
There's no
extends a
fire
little
in there,
bit.
which is what we had constantly on
For the engine
V2
out, essentially, you
because
can
of all of the
run your
cavities
engines
they
a little bit
had.
longer or throttle
There's
up a
no
little bit
fire
more
in that engine
to
bay, which is
account
good.
for the one engine
That's
not
a
being lit.
definite
So right
improvement.
now we are standing by for Seco. And again, we are continuing to go a little bit longer. Five engines still burning on ship.
And I remember from previous flights, you would just see this this orange hue of flames bouncing around in this thing,
Coming
but
up on
there's
T
nothing.
plus 9 minutes.
I don't know which one of these RVACs is dead. It's hard to tell because the orange on the inside here is reflecting from the center engines. I don't know which one's actually out. The sun is not helping.
Shut down. RVACs have shut down. Sea levels are shut down.
And we're in orbit. Well, suborbit, not quite orbit. All right, now we see. We only need those center 3 to relight for the landing, so.
Insertion, but we have shut down again. We did run longer as we were engine out. We were flying with 5 of those 6 Raptors pretty much the whole time.
Wow.
Ship FTS is saved.
It's just ice falling off there. All of these tiles appear to be stuck still, so whatever test they were doing on that flap seems to have done well.
We got a ship in space right now.
Money's on Flight 2 being flawless if this thing splashes down like it's supposed to.
As you can see,
actually, no, I think one is missed. Well, no, that's not where a thing would have been
there in space. We are
attached.
Awaiting
oh no, there is one missing here. I think.
I
don't know. That might just be.
So we're going to stand by for that. We can see the flaps moving here.
It wouldn't be symmetric if there was one there.
Wow, the cheers here in the lobby are certainly almost as loud as liftoff was.
Yeah. Man, a lot of action going on, and you know, we said at the top of the show, excitement guaranteed, and we're only 11 minutes in. We still have a lot more to go here on the mission today.
They have added, as you see this vent here, it's not a vent, it's just a pressure-fed
as we get ready for our in-space objectives.
RCS thruster.
So like I said, we're still
so they've added a lot more little thrusters like that on here for better control, more precise control of the ship compared to the last version. So
some amazing views here. Of the
hopefully
ship.
we don't get the scenarios where it rolls out of control because one thruster dies. There's many redundant thrusters now. So hopefully that is no longer a thing.
As a reminder, the objectives
again, something they learned
today not only included the separation that we saw, but we're also planning to deploy 20 Starlink simulator satellites, as well as 2 Dodger Dog satellites. That's what our internal teams refer to as our
imagine they'll have some data
we saw
on those engines that went out or didn't relight.
Deployments here in a little bit. We're also hoping to
perform and adjust parameters of how they feed it.
That's exactly right. And the relight will look a little bit different this time. We're hoping to get a little bit of a longer duration. Of course, we got to see once we get there. And that relight won't actually be changing our orbit necessarily, but we're doing it more so as a technology demonstration.
So up here, this is your this one here, and down here are your ports for docking to other starships in the future.
For those of you that
and that's your payload bay door right now.
You missed a pretty exciting almost 13 minutes. We had a liftoff pretty much on time, almost right exactly at 5:30 p.m. We did have a brief hold at the T-minus 40-second period, but we were able to proceed through that, and we saw a gorgeous liftoff. Jake and I were able to stand outside and witness that with all of our colleagues, and what a moment. I'll tell you what, it is a heck of a lot louder out here than it was at
feel like the relight on the booster.
A couple things I noticed on the way uphill today on the ship. So obviously it looks like we lost one of the RVACs on the way, but that is a good way to demonstrate our potential engine out capability there. So
exactly.
I think
it was on
saw
purpose.
The 3 gimbaling engines kind of gimbal over a little bit to compensate for that offset and thrust. So that was really cool. That's something I know the team's been, we've analyzed that since Flight 1 all the way back. So it's something that we've thought about quite a bit, and it was kind of cool to see it in action in real life today.
Yeah, absolutely. If you couldn't tell, Jake is on the Raptor team.
Yeah. But hey, one non-Raptor thing I noticed also back on the when we had the shot of the aft flaps, it's a little weird. We have tiles on the leeward side, so not on the side where we're going to see heating. And you might be asking, why are we putting tiles there? I had the same question actually. So I talked to some of our heat shield engineers the other day, and we're actually running. Yeah, here's the shot right here. Great. So the fact that we're seeing all these tiles still on the flap right now is really good, because that actually was one of our experiments where we wanted to test different connection methods on the way uphill on ship, so actually ascent. So it looks like most, if not all, the tiles are still hanging on there, so that's actually a really good data point.
Looks pretty good to me. Now, once again, this view is from the side of Starship, which is basically the second stage of the Starship vehicle as a whole. This is one of the flaps on the vehicle that helps to control its position and attitude as it is orbiting, and also helps to control during re-entry as well. That's a critical phase. I mentioned earlier that we're hoping to deploy those Starlink satellite simulators, as well as perform an in-space relay of a Raptor engine. If all of that goes well, we will be targeting a soft splashdown in the Indian Ocean. We heard from Suren on the recovery team a little bit earlier. They are standing by waiting to receive the ship that we see
Those
here.
are the catch pins. Well, not pins, they're just things.
All
when they
right,
do catch
let's
it, that's
send
what
it
will catch it.
upstairs. Dan, how's it looking?
Hey guys, we are looking good. It does look like we are within bounds of what we analyzed if we were down one of our RVAC engines, so I wouldn't call it nominal orbital insertion, but we're on a trajectory that we had analyzed, and it's within bounds. So team's continuing to work through it with that engine out. They're working through some steps on the engines. We probably will end up skipping the Raptor relight for today, but it sounds like we should still be on for payload deploy, at least at this time. So very dynamic moments right here with the ship, but we do have it in space. It is on a trajectory now, headed towards the other side of the planet, and then a splashdown in the Indian Ocean. It's going to start to get darker. We're heading into an orbital sunset, so we're gonna have darkness for a little bit, and then it'll brighten up once we're on the other side of the planet, and hopefully looking at some good daylight when we re-enter into the Indian Ocean.
I was trying to figure out why those are blue and this is white. I don't know if maybe those are nitrogen and that's oxygen. I don't know. I don't know why they're blue versus white. It could just be the camera angle too, because now that's turning blue.
All right, so we're a little over 17 minutes into flight. If you're just now catching up with us, we did see a liftoff right at the top of our window. Super Heavy getting off the pad, initially lighting all 33 of those Raptor engines, got through a successful hot staging. Initially lit 6 engines on ship, had 1 RVAC go out on the way uphill, but still able to make it into space. And right now we're trying to see if we are going to get into payload deploy.
Payload bay door opened.
Coming up right on the part of the timeline.
They supposedly made this process, I think, twice as fast.
Inside a Starship there. Oh,
yeah.
I see a door opening. Looks like Hal didn't wait. Pez door is open. Just a reminder, we've got 22 deployables in the payload bay today. 20 of those Starlink mass simulators, and then 2 are Dodger dogs, as we like to call them internally. Sitting up their modified V2 Starlink satellites. Those are going to be testing a bunch of components that we're planning to fly on Starlink V3, and we've also got them outfitted with a number of cameras for another tech demo that we're trying out on this flight. We definitely are looking for a way that we can look at Starship's heat shield while it's still in space. You can kind of only see so much from the cameras and the flaps. You can't see everything kind of on the underbelly, and one of the only ways you can do that is if you got something else flying near it. So we're going to attempt to our final 2 satellites going out the door have a suite of cameras on them that are going to be looking back at the ship. We're going to be in nighttime, and so we've got, sounds like we're getting into payload deploy. We'll be in nighttime. They've got some powerful flashlights on them to try and illuminate the ship's heat shield while we fly away from it. So we see some PEZ motion.
Let's see if they really supercharged it. So much excitement. We're lifting a stack.
Pew.
Ooh, they don't drag it back anymore. They just let it. They figured out how not to push one out, then come all the way back, and then push the other one out. They just push, stop, push.
2 down, 20 to go. As a reminder, that's one of the things that we upgraded in version 3. Kind of gave a little soup up to the PEZ dispensers, so those satellites going to move out a little bit quicker than they did on previous Starship flight tests. So first 2 out the door, 2 more on their way out.
And they're not hitting the door. It's great.
All right, 4 down, 18 to go.
All these are just dummy things, but they'll all fall back through the atmosphere right behind the
skills here today.
Starship.
Again, the majority of this stack, 20 of these 22 satellites,
Still slow as balls, but
simulators,
they'll figure it out, I hope.
The same size as those Starlink V3 sats that we're hoping to fly later this year.
They are big, though. I mean, those are probably 7 meters wide. Like, side to side there. Those are pretty big. Because that's a 9 meter in diameter
those 2 satellites
payload bay.
At the very top that they'll look
that's
very
probably like
different.
6, maybe 6
solar arrays.
wide.
They've got a bunch of
5 by 6 maybe
on them that we're going to be testing out.
It's not an insignificant size.
They've got 3 engineering cameras and then 1 other camera that's hopefully going to be giving us some views of Starship in space. But we will see how that works. Again, this very much a tech demo. We're going to deploy those. The satellite's going to kind of try and turn everything on, look back at Starship, and the primary reason we're trying to do this is to get some views of the heat shield. All right, 2 more out the door.
2 more out the door, and I think that counts, or that comes up to 8 total.
As you can tell, the teams are stoked to see this demonstration happening. It's pretty incredible to see this happening live from space. Now, as we noted earlier in the show, but worth repeating, this Starship version 3 is built to deploy up to 60 of Starlink's more advanced V3 satellites. Everything's V3. Designed to offer 60 terabits per second of downlink capacity per satellite. Now, that is 20 times more than each Falcon 9 does today. Incredible.
All right, I think that's number 10 going out the door. Yeah, there it goes. So yeah, the camera view you have on your left screen there is basically right at the bottom of the payload volume. So the kind of dome-shaped structure you see there that's actually the top of the fuel tank.
Then the camera view that you have on the right is an external camera that we have positioned so that you can see basically the light through the open PEZ dispenser door. that you see. That's that sliver of light. We can see the Starlinks here deploying as each one comes through.
It's not as
we
fast
mentioned,
as
we
their
have
animations,
20 of these
but
Starlink simulator satellites, and then
maybe
we
they'll
have
ramp it up on the
2
next
of
one now
these
that the
specially modified
mechanics
as we
of it
call
have
them,
been
Dodger
proven.
dogs here around here. Those, as Dan mentioned earlier, they have some V3 tech on them, some solar arrays, and those will be the last 2 that will be deployed today.
Yeah, that's right. And seeing this, as I think Dan called them turbocharged or supercharged Pez dispenser, it's definitely coming out much faster than our previous flights. So that is really good to see. Yeah, look at that. And especially once we, fill Starship up all the way with around 60 or so of these Starlinks, being able to deploy them fairly expediently, is going to be important for designing the overall mission profile.
Yeah. Now, fans of Starship may know that Starlink enables lots of unprecedented views, both from space, as we see here, and on Earth. In addition to the dozens of cameras on Starship itself, we also have mobile Starlink camera kits deployed in the Indian Ocean.
Yes, Starlink also connects our aerial cinematography units on the ground at Starbase and at other strategic camera spots around Texas.
It's all part of how it all comes together to tell the incredible story of Starship both on and off planet.
Yep.
All right, we're getting low on the stack. It looks like we got 2 more of those simulators to go out, and then it will be time for our Dodger Dogs, those modified Starlink satellites. Just a couple of updates while we continue to watch payload deploy. Did get confirmation we're going to be skipping that relight of the Raptor engine, just due to everything that we saw on the way uphill. Those sea level engines, we're going to use them for a landing burn, though. They are still capable to be used for that. So we'll still look to do a controlled landing in the Gulf, but no in-space relight. All right, I think that's 19 and 20 headed out the door. And then coming up are our Dodger Dogs. So these are modified V2 Starlink satellites. We do have a number of cameras on these that are going to attempt to look back at Starship. We're not going to get this video in real time, but we're going to try and turn it around if we do get some video down. So don't worry, if we get views of Starship from these satellites, we will be sharing. And these will be exciting because, again, they're really a tech demo, getting our chance to test out some of the technologies for version 3. All right, I think that's 18 and 20. My basic math skills are failing now. All right, here we go.
We're standing by for Starship, basically to serve the first Dodger Dogs to low Earth orbit.
4.
And one out the door.
Be embarrassing.
And from this view, you can kind of see on the right side of the satellite, you see some bright white spots. Those are our flashlights. Beneath them, the camera is going to attempt to look back and image Starship's heat shield as it flies slowly away from the vehicle. And there it goes.
Oh my God, those are bright lights. Okay, so they function. That's good.
Be light.
Yeah, it almost looks like the light is just shining right at us there.
If you couldn't tell, we're pretty excited.
And the door is closing, so it'll get dark.
Always
There we
sunny
go.
in space.
Always sunny in space, and that looks like an empty payload bay. So
Sure does.
that's exactly what you want to see there. That's great. So yeah, with payload deploy complete. Oh, you can see the door closing there. All right, there we go. So yeah, with payload deploy complete, Starship will now close its. Yeah, Starship, we closed the payload door, and we're going to continue to coast around Earth all the way to the Indian Ocean. So still a lot of major events to come today. Sounds like we're not going to hit that Raptor relight based on what Dan was saying, but after that, of course, we'll have the atmospheric reentry and splashdown. And with that, we're going to go on another quick coast.
So sit tight, enjoy some amazing space views and the space jams, of course. And we'll be back in a few minutes for Raptor relight. Or excuse me, not for
Mute
the relight,
space
but
jams
we'll be
because
standing
they
by
are not
for,
DMCA friendly.
Atmospheric reentry.
Well, not perfect, but make progress better than the last few V2 flights went, it feels. I think on the booster, it's the first time they've flown all the new fuel systems and everything. Just the way the engine's lit on that one, the bottom half lit, but not the top. And that feels like there was a fuel slosh or something like that, where it was not getting into the turbo pumps correctly. So they just couldn't light, or they weren't getting enough pressure. And the sensor said, nah, don't turn on. You're going to blow yourself up if you turn yourself on. So I'm sure they will make tweaks and figure it out for the next flight. And then this one, who knows why the Raptor went out. The vacuum Raptor went out. Well, that's what the vacuum Raptor's name is, Vaptor. That's what we're going to call them now, Vaptors. Who knows why it went out, but it wasn't happy. I don't know if the orange flash, it wasn't an explosion, because they're all there. They're all still intact sitting there. They do generate a lot of yellow, flamey looking stuff when they turn off. So it might have just been that. It's just like something about it wasn't right, and it cut itself off. Probably what happened there. There was something crazy going on. So, but nothing blew up, and there were no fires, and the ship is in control. So better than we were doing on V2 the first flight. So looks like we got all of our heat shield tiles, and at least from what we can see. So hopefully we have a good re-entry view here. I think one thing we'll notice on here on the bottom is, I believe they're going to be flipping the ship. I'm not sure if they're going to roll it or if they're going to flip it. But they were saying, like, the idea is they want that satellite to look at the heat shield of Starship with its cameras. So they're going to have to flip the ship, because the Pez dispenser was pointing out to space, which is where the satellites went. But the heat shield was facing down, so they're going to have to flip it to look at it. But cool. Well, while we have a break, I am going to take a quick break with Alf, because he's been sitting here staring at me the whole time. And we will be back in a few minutes. So I will not put up my message just in case the views change and get good. So I will be back shortly. Oh my, look at that. Wow. That's cool. Wow. Make sure they weren't talking over that.
Again, this
Nope.
is a view from one of those satellites as we deployed. It looks like this was from the last one out. Flashlight turning on, taking a look at Starship in space. The way
The
this
docking
system
ports.
is set up is the satellites are essentially recording it, then making contact with our Starlink constellation, and then transferring that video back down to us on the ground. That's a Starship in space. So aside from just being really cool, this was our test to try and develop a free flyer that we could fire outside of Starship's payload bay, look back at it, and then do essentially a pirouette with Starship to get a look at the heat shield, where it's going to be really important when we start bringing these things back for a catch, which we are hopefully doing in the not too distant future, as they are intended to be fully reusable. But this will give us an opportunity to look at the heat shield while Starship is still in space. So there was a glimpse. We'll see if we get any more video down from those satellites. But I mean, that's one we've been chasing for a while. So really cool to see it come to fruition here on Flight 12. All right, coming up on 40 minutes into the flight, and
Ooh,
we
you see
should
some
start hitting
lights on Earth
the
below
re-entry
there.
period in the next 7 minutes or so. You'll
All these
start
guys
to
here.
see a light show building up. As we had talked about, we did skip that on-orbit relight of the Raptor engine.
Probably
It's
Africa
not needed
or
for our
could be Madagascar, but
trajectory or
probably
anything. We are
Africa.
on this suborbital trajectory to splash down in the Indian Ocean. We are going to attempt a landing burn. We'll see how they perform when we get there. And just a reminder, we are going to be stressing the ship on the way in. We're going to intentionally do a maneuver where we're going to kind of pitch the nose up and deploy those bottom flaps to really put a lot of pressure on them. So we'll see how it does through that maneuver, and then we'll be doing kind of a final banking turn before we get to a landing burn. So all that coming up in a few minutes. The light show should start.
It's low light, so no DMCA. Think about when you have your phone or just any camera, mainly your phone, and it's really dark outside. It gets pixelated like that because it can't differentiate between colors well. It's very dark right now. The light that we're seeing is just the residual, like, sun. You are loud, Alf. The sun reflecting off of the not exhaust, but the vapor that's coming out of the thrusters. And it's just overwhelmed. They've basically turned up the exposure on this camera so much to get it to see anything. Then it just whites it out when those bursts of light hit. So once we get back over into orbital day, these will improve. Because like when you saw the pictures, the video they showed of the satellite coming out of the ship, that was clearer because it had the bright lights to illuminate what it was looking at and it was able to focus on it. But there's just nothing to focus on here. We'll get there. We'll get to sunlight here soon. I mean, it's getting pretty bright over there on the top part there. Alf. You're a crazy dog. Hi. 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 I'll on your neck. Yeah. Say hi to everybody. Yeah. 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 Why are you going to stay like this, boy? Your ears flapped up. Here we go. What are you doing? Am I taking up too much of the couch for you? Huh? Was there not enough room for you on the other 2/3 of the couch? See, it's getting clear now. It's less pixelized now that we got more light. It's clearing up. Nope. I hate web browsers that leave freaking cursors. Hang on. Fix that cursor. Driving me crazy. Still there. Oh my god. I hate. I don't know why cursors show up in browsers so much now. Well, it looks like we are positioned for re-entry. Down to 98 kilometers and falling. It's always interesting looking at the tiles because even when you look at the ones on the main part of the ship, every single one of them is as a check mark or a circle or something signifying somebody checked this or this is this type of tile. Like the tests, I'm sure these symbols mean, well, this is attached this way and this is attached that way and these are attached the normal way. But every single one of them has a little circle like they've checked it at the top of it. So they did the same thing with shuttle. You could see them on shuttle too. You could see little markings of when they checked them. Nope. Oh, we're starting to get some, it looks like plasma E, doesn't it? This is the top of, this is one of the top flaps looking down at the bottom of the ship. These are the bottom flaps here. Oh, that was odd. Must have hit a bubble in the atmosphere. Yeah, definitely getting re-entry stuff now. Go back to commentary so I can unmute this. So bright.
Welcome back to Starship Flight 12, the first test flight of Starship version 3. As Dan mentioned earlier, we were able to make contact with the modified satellites just shortly after deployment. And as you may have seen, we got some sweet views of those sats looking back at the ship. Pretty cool to see.
Yeah, those views were incredible.
Now, as you see on your screen, currently the ship is re-entering the Earth's atmosphere. This is the plasma starting to build up on the exterior of the vehicle. Now, we do not plan to recover the spacecraft today, but rapid and reliable reusability is the ultimate goal.
Yeah, that's right. And re-entry is a critical phase of flight, and we need information on how the ship's systems perform. Re-entry is an extremely demanding portion of flight where we essentially have to scrub all of the energy we used to launch
I just
the
saw
rocket
some of the satellites re-enter in the background of that last shot.
18 million pounds of thrust that we had off 33 of those Raptor engines.
Just a little.
Just a little.
I think that's what
We're
that
now
was.
in
I don't know what else it would have been.
Several minute burn on the ship. We're now basically undoing all that energy here via aerodynamic braking, essentially.
Yeah, you see these things
and
here?
Of course, Starlink is a big part of it, as that's what allows us to actually gather this data and
they look like
show
they're
these live
streaking
views.
into the atmosphere.
And again, the data gathering is really the main reason why we're doing these flight tests.
I don't know.
So Starlink provides us just one more path to collect that data that ultimately allows us to rapidly iterate Starship's design.
Now, if ship manages to make it all the way through re-entry, we'll collect valuable data on the spacecraft flying through the Earth's atmosphere at these hypersonic speeds, which is basically more than 5 times the speed of sound. Now, we do anticipate that it might be a little bit of a spicy re-entry, so we'll see how far we get. Re-entry is typically a portion of flight where we don't have communications with the spacecraft because it's re-entering at or around orbital velocity, roughly 8 kilometers per second, or for those of us that think in other units, roughly 5 miles per second. At those speeds, the spacecraft is moving through the atmosphere, and it creates that plasma field that we saw forming around the vehicle.
Yeah, and although the plasma looks really cool,
See, doesn't that look like it's stuff breaking up now?
Frequencies.
Burning
so
up in the
not
atmosphere?
Uncommon to experience brief blackouts.
That's got to be what that is. What else would that be? If we're over the Indian Ocean,
Of course,
it ain't
thinking
land.
long-term here, Starship is designed to land on Mars where there are no runways or other humans to help out. That's
I
where
don't
we're
think we've ever
going
seen that
with
before.
the propulsive landing instead
Could be
of a
wrong. We
more
could be over
traditional
land right now.
in-flight
Oh no, I'm
parachute.
looking at the dot on this thing. This is the ocean.
Propulsive
That's
landing,
got to
not
be
only,
the
again, is
satellites
it more
re-entering.
cool, but it
Alf, it's
enables
so
a
loud.
a more rapidly reusable rocket.
Yeah. Now, we should hear some call-outs as the ship makes its way back to Earth. When we hear entry max heating and entry max Q,
Come sit.
that means the ship has made it through the maximum heating and aerodynamic loads that it will experience as it returns. So if we make it through those, we're doing pretty well.
Yeah. And you can see in the bottom left right now, we're at 23,500 kilometers per hour speed. That's just a crazy number to think about. But as we keep progressing in the mission, we are going to hear a call out when the ship is transonic and then subsonic. So transonic refers to the period of flight where the velocities of airflow surrounding and flowing past the vehicle are concurrently below, at, and above the speed of sound, kind of in that Mach 0.8 to 1.2 range. And for reference, commercial jets have a range of cruising speeds, but mostly fly around Mach 0.74 to Mach 0.85.
This stuff there? What is
And
that?
after we hear the call out that Starship is transonic, we should hear the call out when Starship is subsonic. This refers to speeds that are much less than the speed of
You see the
sound.
tiles
So at this point in the
glowing
flight,
here.
ship's velocity will be slowing down.
Something
We definitely have a crowd still
liberated,
here in
it
the
feels there.
lobby of SpaceX headquarters down here at Starbase, Texas. Everyone is, loves watching ship re-entry. It's always such amazing
Flaps are going
colors.
to be the
This must be what it
bugger
feels like to be one
constantly
of
for
those
re-entry.
praying mantis shrimp or mantis shrimp. Can't remember exactly what the name is, but the ones that see in billions of colors. This is the closest I feel to being one of
Could
those.
also just be the tile
I think
fillings.
one other thing that's cool to point out right now is look in the bottom right. You can see where we are on a globe there. We're squarely in the Indian Ocean already, and we've only been flying for 53 minutes.
Yeah.
So pretty crazy. We went all the way from Texas to the Indian Ocean in less than an hour.
Yeah. She flies pretty fast.
She
that
flies
is for
very
sure.
fast.
Because in between all of the tile, it's underneath it, but then it comes up. They call it like the crunch wrap, is what it is. It's like all in between.
Right, so the light show
It's meant to
continuing.
give
We
and
are
take as they
through the
expand
period
and
of peak
contract. So I'm
heating.
wondering if maybe little
We'll be
bits of that are
looking
what's
at
coming
the
off there.
peak pressure coming up in
Could
the
have just been a
next couple
tile
minutes.
fell
The
off
next
too.
10 minutes are probably going to be the spiciest.
Looks
of
like we
entry
did lose a
today.
few tiles
As a
here.
reminder, we are going to be doing some stress work on this ship, where we're going to do a maneuver where we kind of kick the nose up to fully deploy those aft flaps to really get a good test of the structural strength of that part
Those
of the
tiles
ship.
weren't-
We did that on one previous flight test.
Those were
on
just the test
version
tiles,
2.
though.
We're going to try and do that today. Since we did skip the in-space burn, we're carrying a little bit of extra propellant in our header tanks up in the nose. And so that's going to put a little bit of extra stress on those forward flaps as we come in. So we will see if they're able to hold through that reentry. So that will be another watch item. We did skip that in-space burn, but we are expecting at least 2 of those sea level engines to try and ignite for a landing burn. We entered the entry period in a good attitude, so hopefully making our way to the targeted splashdown point. We've got that Starship recovery team standing by, and we should be about 10 minutes away from splashdown. So a lot of excitement over the next couple of minutes. Kate and Jake, let's see how Starship holds up on the way in.
Yeah, and we just heard on the nets there that engine chill has started. So essentially what that means is we are prepping the landing engines by getting them down to temperature ahead of that landing burn later in the mission here.
And on a lot of our previous flight tests, we've been removing a bunch of the tiles. If you've watched those, we were really intentionally trying to push ship beyond its limits. On the last flight, we even had basically a hole get punched into the liquid oxygen tank that you could see when we did the landing burn into the ocean, and this ship was still able to make it. But right now, we're really going to be testing the structural strength of these flaps on the way in. Again, this is a flight test. We're trying to intentionally find where our limits are. And in this view, you're looking at a whole bunch of tiles. I think Jake talked about it earlier. We bonded some additional tiles to the leeward, or kind of the metal side of Starship, to see how those different bonding techniques would hold up. And looking like we've got quite a bit still attached.
Yeah, and as we're going down through the atmosphere here, we are at about Mach 16.1. So still extremely fast, although we have, scrubbed off a substantial amount of our speed already. Altitude at a little less than 60 kilometers.
All right, we're about 8 minutes away from our targeted landing and splashdown time. Again, this is when the ship's going to start really
Ship
getting
is approaching the
ringer.
end of the peak heating region.
Just heard the call out, getting to the end of the peak heating. So
I was going to ask.
The highest temperature the Starship's going to see during its reentry.
This camera angle changes as it is attached to the forward flap on Starship. So we're actually experiencing the articulation of that hardware, helping to steer the ship down for its precise landing in the Indian Ocean.
Yep, that is just a really cool, kind of cool piece of perspective there. I know some people say it makes them a little seasick, but I definitely love it. It makes it feel like you're really riding along with the ship on the way down.
I prefer to be on
and
the
aside
inside
from
of it.
just looking cool, all
Where
these
it's
camera
not hot.
views providing just really
Pump
critical
up.
data on how the heat shield, how the flaps themselves are holding up. That's why we've got these in the flaps and then all scattered all around the ship so you can see how they hold up. There's some internal to the vehicle too and we're getting all of this
I'm
video
not
back
seeing
via
burn
Starlink,
through
even
on the
as we're
flap
just
like we saw on
enshrouded in
every other
plasma.
flight.
We're able to kind of operate at a high enough frequency to punch through, and that is blue ocean and sunlight you're seeing just beyond the flap. So we are
Here you go,
coming
boys. Sit down.
into daylight.
Thank you.
Hopefully splashing down in the next 6 minutes or so
Don't have to lick.
in the Indian Ocean. We've still got a couple maneuvers lined up where we're going to be really stressing the flaps on the ship. So
ship has passed through the peak heating region. External temperatures are coming down.
Wow, that is incredible news. As Dan mentioned, we were expecting this reentry
it's
to
enough
be
licking, boy.
super spicy.
I don't need
but
more licks.
Excellent news that we're now past that period of peak heating and that now the external temperatures are starting to decrease. Those heat shield tiles there on the belly of the ship really doing a ton of work to burn off all of that inertia that the vehicle had prior to re-entering the atmosphere.
Yeah, and you can tell by the G meter down on the bottom right that we're starting to pick up a couple more Gs here, so we're definitely entering the thicker part of the atmosphere where we're scrubbing off all that energy, like Kate's saying.
The sunrise on the left side of the clouds there.
Just about 5 minutes or so to go. We're coming up shortly on the maneuver where we're gonna, it's affectionately called the flap slap, where we're going to kind of pitch the nose up on the ship, and you're going to see those aft flaps, the ones in the very bottom, fully deploy.
There you go.
Ship is at peak dynamic pressure.
And we're now
I
at
mean,
peak
what we
pressure.
can see of tiles looks pretty darn good.
Ship flap load test has started.
They're waving.
Looks like it's holding. Again, the intent of that was to put just a lot of extra stress on those aft flaps. We are expecting the forward ones too to see a little bit of extra stress as we've got a little more propellant in our header tank, so the area right at the very nose of
Ship
Starship.
flap load test is complete.
And we're through that test.
There we go. And we just did that test at Mach 7, just for reference there. So we are still going incredibly fast.
All right, we are just about 3.5 minutes or so away from our targeted landing burn. Again, we're expecting to try and see 2 of these Raptor engines light for the landing burn. Nominally, we plan for 3, but we're going to give it a try with 2. Hopefully, we've got
Ship
Sirens.
is starting the RTLS banking maneuver.
Oh, please.
And that right there, so we're starting a banking maneuver, and essentially what that is when we come back to Starbase, or when we plan to come back to Starbase, the trajectory is designed so we'll essentially swing out over the Gulf and do a swoop maneuver to then come back to the towers for catch.
Pretty nice view.
And so we are doing that exact same maneuver as we head towards our targeted splashdown in the Indian Ocean.
Yeah, and that call out there that we heard, RTLS, stands for Return to Launch Site. So definitely a pretty cool thing we're demoing here on the ship, you know, as in the future.
Interesting
we are
how
gonna be
this
trying to bring the ship back to the
heat
launch
cloth
site.
or whatever
It'd be
they're putting
absolutely
here.
insane.
It cracked
Absolutely.
some.
But of course, we want to
I don't
test
know if that's
out
expected,
these
but it
maneuvers,
did. I
these
mean, it protected the
principles
ship
prior
where it
to
was supposed
actually
to.
bringing the hardware
So that's
back to
good.
the pad. This is the same reason why we were, intentionally not trying to bring the booster back to the pad. So
Maybe that's something
we're
they
trying
just
all these
expect
things
to
out
quickly
in this
replace each
developmental
flight. I don't know.
phase of the vehicle, and really proving what a test flight is.
Absolutely.
Dynamic pressure is coming down.
All right, we heard there dynamic pressure coming down, and I'd say we're in a pretty good bank right now.
Yeah.
Executing the power slide. We're about 90 seconds away from our anticipated landing burn.
Just a rocket.
Clouds coming up, pretty sunrise on the other side of the planet.
Wow.
Starship is subsonic and is on target.
The crowd here reacting to that call out, letting us know that we are on target for this precise landing in the Indian Ocean. This will once again be a soft splashdown. We should get some pretty cool views from the recovery team who we chatted with earlier. They are standing by to receive this ship. Once again, this is the first flight of our completely redesigned Starship version 3.
Yeah, and if you remember the suborbital flights from a few years ago, this is very much the same regime that we're in here. So we're sub 15 kilometers, executing what we call the belly flip maneuver.
Yes, serial number 8, the first belly flop. I remember it well. Just some really amazing views of the Earth as the ship is coming back home.
This tile damage
Thanks,
over here,
Starlink.
but that's literally just painted white, so it just chipped off. That might have been the little bits we were seeing, was the paint coming off the tiles. That's
Yeah,
probably
you can
what we were
see
seeing.
the aft flap there making minor corrections.
Starship is turning for final approach to landing.
Wow, look how much that's
Look
turning.
at that turn.
There we go. Minor corrections and a
Damn.
full turn.
What's gonna have to do to get
Starship
back to the
doesn't
launch
fly like
site,
an
though?
airplane. It's a lot more like a skydiver. Full belly flop on the way down, using those flaps similar to arms to help change the path of the air over you. Coming up real soon. Again,
This is
going
a
for
vent.
landing burn, trying to light 2 of these Raptor sea level engines.
I think. Yeah, it
Landing burn
is.
startup.
Landing burn
It's just
startup.
going really fast.
2 engines lit.
Oh, drone missed it.
Successful flip.
Well, that seemed to come down pretty well.
Good shut time.
And kabloo, show it. Yes, they showed the explosion. Used to cut away from that.
Amazing. That ball of fire is exactly what we wanted to see for the ship today. As weird as it may sound to hear, but it is the truth.
Absolutely wild. At the beginning of the show,
We're pretty hyped.
we guaranteed excitement at the beginning of the show, and I'd say Starship delivered.
Absolutely. An incredible day for Starship. That was the first flight of that completely redesigned vehicle. As you can tell, the teams are incredibly proud of what we just saw.
Yeah, V3 definitely showed up. That was amazing.
Yeah.
Yeah, we've pretty happy crowd in the control room behind me, I will say. It's probably the most excited I've seen a lot of people in a really long time. On target landing. Wow. Actually, let's jump over. Hey Tyler, how's everyone holding up in Hawthorne?
We're having a great time, Dan. Thank you so much. That was another
Well,
exciting
you can see a
Starship
buoy
flight in the
cam in the
books, and we hope that
background
you
there
enjoyed those
in the
awesome
control
Starlink
room
views.
there.
So congratulations to the team at Starbase and
You know
everyone
they got
here and
video
around
they're
the
holding
company.
out on us from.
So many employees have contributed to the Starship program as we continue to iterate and make progress towards a multi-planetary future. So that wraps it up for us here in Hawthorne. Thank you guys for tuning in. And back to you, Dan.
All right, thanks. So just to recap, we lifted off right at the top of our window, 5:30 p.m. Central Time. We were able to see the booster light 33 of those Raptor engines get off the pad and ascent over the Gulf. Successful hot stage separation. Initially lit 6 of those Raptor engines, lost one of the RVACs on the way uphill, and then the booster didn't complete its full boost back. Its mission ended a little bit early, but landed in the clear area that we had set in advance. Once we were on orbit with ship, we were able to get through our payload deployment, 22 satellites, the 20 simulators, the 2 Dodger Dogs, which successfully turned on cameras. We'll see if we got any more views from those. So obviously stick around. Skipped the Raptor relight, but made it through re-entry, on-target landing in the Indian Ocean. You saw those views. Starship made it. It's been a long time coming. We're really excited to see this vehicle fly, and there are several more on the way. So that's going to do it for me up here. Send it back down to Kate and Jake and everybody who I hope is at least a little bit excited down in Star Factory.
Oh, yeah.
Awesome.
It is absolutely insane down here. We would, of course, want
Still
to thank
replays
the fine
of
people of Cameron County,
the ship as
including
it
the
was
residents
flipping.
here at Starbase,
See what the heat
as
shield
well as
looked
the
like.
Coast Guard, the Federal Aviation Administration, the Government of Mexico, and, of course, the Australian Space Agency.
Yeah, so honestly, just huge congratulations to all our teammates here at SpaceX and everyone who's supported the Starship mission just in general here. It's been a massive effort, really incredible.
Yeah, there's a lot of people that worked really hard to make things look easy, so shout out to those teams. Now be sure to follow SpaceX on X for updates and more exciting views that we didn't get to show you on today's live program. I have a feeling we'll see some pretty amazing stuff come from those demonstration satellites that we were able to show some initial footage of. Now, if you're interested in more launch coverage, head on over to our profile on X. We also have spacex.com/launches for you to check out for the most up-to-date information. So thanks to all of you for tuning in. We're going to close it out and celebrate with our colleagues. Thank you so much for tuning in.
Skip
and have a
back
great
for
night.
some.
We'll see you next time.
Seen that. All right, so let's see. Let's go back. Let's go back. All right. I want to see the flippy bits where you can see the heat shield. Oh, it's not. It goes out of frame there.
Successful flip. Buoy cam
Starship is
catching
landed.
it.
I'll get the top one again. All right. I mean, that looks like a heat shield that went through re-entry. It went through a re-entry. You don't have all of the orange color this time because they didn't have any of the metal tiles like they were trying before. This is just what happens, but it's hard to tell if anything's missing because it's not the greatest of resolutions. On the video, at least. I'm sure they got pictures of it as it tipped over and blew up. But you can still see the painted tiles on there. Trying to see if there's anything obvious missing. A lot of that just kind of looks like the white crunch wrap stuff they put between the tiles and underneath them. It's hard to tell if these are missing tiles or they're just different colors. Alf, why are you so loud? Stop chewing in my ear. I feel like it's just discoloring because if they were missing, there'd be a lot more going on, I would think. We'll see if their satellites that they deployed got pictures of it before, because then you'll know if they were missing before or after, if they are missing. And kaboom! Yes. And that was intended. That way it sinks. Otherwise, it would just float out there forever and be a danger to shipping. I mean, it did pretty well. I mean, for the first flight of a completely redesigned internals of these things and some external stuff, didn't do too bad. Let's see if there's anything else of note that we can see here in still pictures. Just crazy how fast that thing, like this bit. See if I can't change it yet because it's still technically the live stream.
Landing burn startup.
That.
2 engines lit.
That's not how it's going to land on the moon. Because the moon doesn't have the gravity that Earth does, so it doesn't need to do that.
Buoy cam estimate.
Good shot time.
And that was with only 2 of 3 engines. Boom. So that was an intentional test to see another engine out. So they unintentionally test one engine out capability, and they intentionally test another engine out capability. So, but no, that was pretty impressive first flight. It could have gone way worse. It's cool seeing, like, the sun's rising because you got the side of the clouds illuminated and it's not on the other. Some nice views.
Expecting to try and see 2 of these Raptor engines light for the landing burn. Not.
But, well, cool. Let's see if they've got any of these other guys and see. Okay, that page blew up. Trying to see if these other guys have any replays that they're showing. What are they showing here? Like, there's no rocket there. Oh, there we go. Oh, the sound on the tab. Yeah, they got off faster than last time. Last time it just kind of, the way they had to they just let it go as soon as its thrust to weight ratio was high enough. It just kind of lumbered off there. This one, they were able to full throttle it and then let it go. So it got out of there quickly. Whoa! I just noticed the Gateway to Mars sign. It is completely destroyed. Gateway. Yeah, that would be the exhaust. We all, there was a lot of comments about this not surviving a launch. I don't even know why they bothered with it, but all that exhaust and pressure wave just goes right over top of that wall. The top deck started sooner than I expected it to. I thought it was going to be after ignition that would kick off, but I guess it makes sense to get it early because if it doesn't work, you don't want to go. But it'll be interesting to see what the pad. I mean, the pad doesn't look. I'm looking at another. Oh, he switched his views. I was going to show you the other view. It looked like nothing had launched, which the previous launch mount thing looked like it was rusted to hell instantly every time it launched. I'm curious why the one Raptor went out of one of the outer rings. I wonder if something got into it or something weird. But I am curious what the top of the launch mount looks like once we get some pictures of it, because that's going to determine how fast they turn around the launch pad. Me.
So.
What amazing work to the team. Thank you so much for all of you that have contributed to this. We are a team of space.
Oh, he just changed it. All right, well. So let's pause it then. So that's post-launch. Obviously, the Gateway to Mars sign is destroyed, but the mount doesn't look bad. Like you don't see a bunch of discoloration like you saw on the other one. I don't know what the very, very top looks like, but that's supposed to have been covered by all the water. So it doesn't look much different than it did before the launch. From this view, at least. So it seems like that worked pretty well. So that's good. Look how much water that was. How far that was shooting. And then obviously it disappeared as soon as the rocket started. Wow. Look at the shock waves coming off of that. It's just amazing that this stuff doesn't tear itself apart with that much power. It may be why one of the Raptors went out, but probably not. It's probably just they've only built a couple hundred of them, so they gotta. There's gonna be some defects. Always are. But yeah. It's so bright. It was quite purple still coming out. I was hoping it was gonna be a little more blue than it was. The booster is more powerful than SLS. Versus let me see. So the SLS is 9.5 million pounds of liftoff thrust. So that's the two solid rocket boosters, and then the 4 RS-25s on there. That super heavy is 18 million pounds of thrust. And that was I don't know if that's or a V3 Raptor or V2, but still it's almost double. It's almost double right now. The SLS, I don't know that we're going to see Block 2. I think we're only going to stick on Block 1. Can get 27 tons to the moon. This would be able to lift 100 plus tons to the moon. So 4 times as much mass. So it is definitely the most powerful rocket. If we look at God, I hate Super Heavy Booster Starship versus why am I being dumb here? Saturn V. So Saturn V did, these are not in the same units. I hate AI. AI asking these type of questions is stupid. It just doesn't, it has no clue. And this isn't even accurate. It's telling me how much it takes to get to the moon. I want to know launch. Let me see. Rocket. These are all modern ones. It doesn't have. It's more powerful than Saturn V. I'm just trying to find what Saturn V was. Saturn V was 7.6 million pounds of thrust. So you had 9 on SLS, so that was more powerful than Saturn V. And then you've got, what I say, 17.5 million or 18 million pounds of thrust on this. The N1 Russian rocket that never successfully fully launched was 10 million pounds of thrust. So it was a similar idea as this. It's just built in the 60s and 70s, and they didn't have the technology to do it. They didn't have gimbaling engines. All their engines were fixed, I believe. They were all fixed, and like this gimbals engines to steer, basically. They were using variable thrust on those engines to steer it. And the problem with that is as soon as one engine failed for some reason, you had to turn off the engine directly opposite of it. And then you lost steering capability. And it just cascaded into a big explosion by the FTS at some point. So I clicked a picture of the N1 and then it completely disappeared. No, stop it. Stop it. So this was the N1 rocket, the Russian one. So they had 6 engines in the middle here and then 24 on the outside. They were none of them gimbaled. So they would use these outer ones to adjust thrust to steer the thing, but this thing just never, they didn't have the technology to make that work. It just never succeeded. So that was the closest thing to this that ever existed. It just never successfully launched. So yeah, so this is 16.7 to 17 million pounds of thrust with those Raptor engines. It is a beast, but that's what's going to get you payload to orbit. That's the only way you're going to build things in space of any significance. The space shuttle was really kind of the last big thing that could carry bigger things to orbit. What was its payload capacity? It could do, I don't know what that is. Kilos to tons. Where'd it go? Hello? It could do 29 tons to low Earth orbit. So, but it had that big payload base, so it could get big chunks of things up there. So that's what these larger rockets are for, is to get those big chunks of things up there, because you can't get everything down in a little fairing on a New Glenn or a Falcon or a Vulcan rocket. You got to get bigger things. That just looked like that view of that separating there. Why'd they go away from that? It looked like it was it didn't move in the direction that might have been what actually happened there. It's very possible. I don't know why I do that. It's very possible that when nope. No. All right, let me refresh this so I can actually. There we go. Nope.
If all of that goes
Mute. Come on. Those are some pretty views coming up. So yeah, so I guess we can go back to, you asked the question earlier about what was that shadow in this shadow here. That's the exhaust plume here, shadow into the Gulf. So same thing happens on rocket launches in Florida and everything. So that's normal. You just don't see it from this angle because other companies don't have Starlink. So that's the only reason all these views exist. But I feel like, now that I think about it, what might have happened here. So there is no, when they launched the last one, the hot staging ring, they put a plate basically on a side that they wanted when the ship's engines lit, it to push the booster that way. I wonder if it didn't push the way they thought it was going to. So all of their internals that were meant to keep fuel in the right place, pressurized in the right place to get to the engines, didn't have it in the right place at that point. I wonder if that's what happened here. So it may just be as simple as, okay, we light the engines on the ship a little bit differently next time. I say simple, but there's rocket science involved there that I don't know. But if you notice, when the engine's light, it lights the bottom one and the top two and then the middle ones. So it's like that might have been the right order, but I wonder if it just didn't kick it the right way. I don't feel like it should have gone to the left there. Because if you look at the engines that are lighting on the booster here, I didn't know they were even going to light the outer ring of engines. But there's 4. They had 5 going, and then they turned some turned off, and then some outer ones. I don't know what they're doing. I feel like this was supposed to push either up or back this way, like up or down, not sideways. And then that made the fuel not basically slosh away from where they expected it to be. I wonder if that's what happened. I don't know. It felt like, and you also see it spinning. There's like a rotation on it. I don't think there's supposed to be a rotation on it. And then it spins. Yeah, I just feel like it didn't separate the way they expected it to. It actually lit. This is not reflecting what I see. Well, these aren't necessarily lit. They're trying to light. Well, no. It did a lot better than this shows. Maybe they didn't light healthily. Because you can try to relight. You can try to light a Raptor. Because you see the ones that are glowing on. There's a lot more glowing on there than this is showing glowing. But that doesn't mean they're healthy. They could be trying to come to full power, but they're not going to make it for some reason. There's a lot more engines lit there than this is showing us. But I feel like that might be the issue that happened here. Is it went to the side instead of... Because when you look at this, they launched from right here. And the idea is the ship and booster are currently going out over the Gulf. So they're not going toward land, they're going away from land, so they're going into the Gulf. And you basically want the booster to flip in a way so that it comes, when it lights its engines, it is slowing its going out to the Gulf down and coming back, right? This angle doesn't do that. This angle pushes it off to the side. And it doesn't feel like that's the way it's supposed to go. That's why I think it's probably was supposed to push it down more this way, down toward the clock at the bottom. And then it probably would have had a better outcome. Because this direction just doesn't make sense for bringing it back to the launch site. So it may very well be a software change, which is crazy to think, but it may just be, well, we just need to time the engines on the ship a little differently. It could also be that the engines on the ship didn't light in the order they expected. Because like right here, it lit the bottom one first, then it lit this one, then it lit this sea level Raptor, then it lit this Raptor, and then it lit the other 2 sea levels. And I wonder if that wasn't the order they were expecting them to happen in. It was clearly some not all at once order. It just didn't have the effect on the top of the booster to push it the way they thought it was going to. Because we'll look at a picture in a second. Well, actually, when I go back, you do see all these light up except one in the middle. And then more of the outers. Looks like maybe they're lighting every other outer. Nope, they start lighting more of them. They just didn't all successfully relight. The top of the booster doesn't... It looks intact. It looks fine. It's charred because you just lit some engines on it. But, I mean, that's what the expectation was. So they showed it earlier on. I don't know if they showed it in here or not. I know there's pictures of it on the internet. Let's see. I don't know if they're going to have it on this somewhere soonish for me to see, or if I'm going to have to go search for it. That ship. I'm looking for the top of the booster, a good view of the top of it. Stop. Actually, the static fire looking down one that I had earlier would have been a good one, I think. Where was that? How far did I have to go to get that? I had to scroll forever in this feed to find that. Oh, there we go. This will work. So you look at the top of this booster. You see these little, like, no, they're not circles, but they're shapes, different curved shapes. Those are extra steel plates on top to reinforce where the Raptors are going to light and hit it. And when you look at that, where they are expecting the Raptors to hit, it doesn't look like it would go to the side. It looks like they are intending to gimbal the one sea level Raptor on the bottom here toward this side of the inside of the booster here, and then the other two the Vaptors. I keep calling them Vaptors. What we're just calling them. The vacuum Raptors are shooting right on their stationary spots. So this one Raptor here is further away from center than these two. So that's like they were trying to push it this way. Like if it was going to lean into the tower, that's the way they were trying to push it. But that's not the way it went. It went a completely different way. Where is it? It went sideways because there's a grid fin here, there's a grid fin here, and there's a grid fin here. This is the back where there's not a grid fin. That's the way I think they wanted to push it. So maybe there's actually pushing it up on the ship, but it definitely wasn't sideways. So I don't think I think the order that those lit on the ship matters. So I think this first one lighting is okay, but I think because they lit left to right, it probably pushed it wrong. And then everything was out the door with how they expected fuel to flow. So maybe not as bad as it looked. Just some tweaks to order of operations. But that's a cool view. Already can tell the Earth is round. Yeah, at that point they shut those off because they're like, no, don't push it back toward land. Just let it keep going out to the corridor down in the Gulf to hit the water very hard. They tried to relight them. I didn't expect that. Like I didn't expect them to even try the landing burn here. But because that thing was not on a stable. If you look at the engine bells here, watch as it's billowing there. Watch them rattle like they are flexing because the pressure aerodynamic pressure on them is so crazy. Part of me thinks that isn't all ice falling off anymore. But I did not expect this landing burn to happen or even be attempted. They tried, and then boom. Dead. It blew up. Well, I don't know. Did it blow up or did it hit the water? There's a cloud. It's through the cloud. Oh no, that's water. That's the ocean. That's the surface of the ocean or the Gulf right there. It splashed down just very hard. So Yeah, it was going at 1,400 kilometers an hour. It got from the clouds to the water very quickly. Not the way it's supposed to go. But now this part, you can also tell on this, I think, it's got to be this one that's out. And my reasoning for that is twofold. One, look at the top of this Raptor and its nozzle, and look at the top of this one. This one's cold. There's no way that it stays cold like that if it's lit. The other bit is the sea level Raptor. So these guys gimbal for steering purposes. They are much closer, these two, and probably the third one even, is much closer to this engine than they are to this engine. So they're gimbaled toward here to compensate for the fact that this one isn't burning. So this is the one that went. So it doesn't look like it was like an explosion. It just looks like something failed, or it didn't start right, or something failed clearly somewhere. It might have been the turbo pump failed or something. Who knows? But it didn't explode and start a fire, which is big, because every other time we've had an engine problem, it started a fire. So they've clearly gotten that under control fire-wise. But so many views of things that we just don't get from other rocket providers. Yes, not a RUD, not a rapid unscheduled disassembly. And technically the booster wasn't either. I thought when the engines lit, it exploded, but when we rewatched that, you saw it go through the clouds and you saw the sea come up very quickly, and it hit the ocean and exploded. So it was rapid. It wasn't unscheduled, because you could have pinpointed the time it was going to hit the ocean. But it's just, you look at this compared to the last flight of V2. This engine cavity is so clean. That's one of the biggest advantages to these Raptor 3 engines, is that they don't need all this extra crap to protect things, because they are naturally protected now. Because before, they would have up to the engine bells here and down to the engine bells here, they have all these extra heat shielding going on. And what was happening is any leaks, because these aren't perfect. I mean, the seals aren't perfect. I mean, you hear about it when they were fueling SLS. Just the connections for holding pipe, cold, what's the word I'm looking for? Super chilled liquid oxygen and hydrogen and stuff like that is very hard to do, and you get leaks, and there's an expected amount of leakage, right? So there's going to be a little bit of leakage of fuel and oxidizer in here. But before, because they had all this heat shielding above these engines here, holding to protect them, if there was any leakage up on this part of the engine, it would gather and build up inside of those cavities. And then if anything caused it to ignite, you'd get a fire, and then you'd have to have fire suppression systems and all that stuff. And that was terrible. Now you don't have that, because at the top of this is the turbo pump pushing the fuel into it. That's it. It's like, if there's a leak, it's just going to come out here and dissipate. It's in space at that point. So it's just going to dissipate and leave. So you don't get fires. You probably still could get fires. I'm not going to say you can't, but it's much less likely without having extra cavities where stuff can build up. That's why they have, like, when they were fueling SLS, they would keep talking about what the percentage of hydrogen, what the hydrogen levels were at in the different quick disconnect plates and cavities, because it's basically after you hit, I think they were saying like 16% hydrogen to regular air capacity, it becomes, I think it's well above that. I think they said it's closer to 25, but they set it to 16. But you get to a certain level, then it becomes dangerous where it could just combust, right? So that's what, now that you don't have the cavity, it can't build up because it just vents out the space at that point. So going back and looking at it, it feels like it was a much bigger success than it looked. It feels like there's just some minor things they need to tweak, and they will get it on the next one. It's still better than the first flight of V1 and the first flight of V2. They both didn't go well. Like V1 just started toppling, and the flight termination system didn't even make it explode. It had to tear itself apart before it exploded. V2 just didn't make it. Didn't make it. I don't think it made it to orbit, but overall, I think that went pretty well. This whole contraption just feels over-engineered to me, but I'm not an engineer. I don't know how to build this kind of stuff. There's probably a reason all of this exists and why it has to be this way. I mean, this is also purpose-built to deploy their Starlink satellite, so it's something crazy weird. But when we go to the moon, it won't be this Pez dispenser door. It'll be, the HLS will have a way for people to get in and out, and an elevator. So that's the plan there, at least. Where was the... Where did they show the video of the satellite leaving? There we go. Alrighty, will do. I'm sure there will be a bunch of stuff coming out in the next couple days. Enjoy your show. Everything looks the same in space. It just looks so dirty once you get to space. I don't know why. Oh. Oh no, it keeps going. It's just you couldn't see it. Okay. So you can tell they use different adhesives between these two patches of things because one's purple and one's not. You still got a little bit of your fuel left down. It's not fuel. It's still ice. I don't know how much fuel is left down there, but mostly gone because he used the header tanks up in the top of the ship to do any in-flight burns and then the landing burns. You can't even see the flaps down here. Oh, wait. No. Wait, hang on a second. This is the methane tank. You can't even see the bottom of the ship. Because these stringers here is the top of the methane tank. And then from here to somewhere in this area is the payload bay cargo area. I don't know how far up it goes on this side. These things are for, part of it's for fueling. Part of it is, so I think, is going to be part of how they transfer fuel. These are your docking ports, and then these somehow will connect to transfer fuel. It kind of looks gold rather than steel color. Interesting. Oh, that's what happened here. They turned the lights on inside. It screwed the exposure up on the satellite, and then the door covered them up. And the door closes down, and then it pushes up against the side of the, oh, they cut it off, but against the ship to seal and pressurize. this part, I'm pretty sure that's the Starlink, the dummy Starlinks. Because I first started seeing them where? Here. I saw them before this because there weren't as many dots. But at this point, we're over the Indian Ocean. There's not going to be city lights below us. And these things move. Like they're moving. They're not just the same pattern over and over again. They're moving like it's satellites breaking up. Go back to see where they were bigger. Yeah. See if I can find where I first started seeing them. Because it was very clear that they were streaking. Go streaking! Where is it? Here. Like they just come into light here. Like they are falling through the atmosphere as well and burning up. That has to be those dummy satellites re-entering and burning up. Because now they'll start breaking apart. Yeah, I mean, look at this one here. Right here in a second, this guy here, he's going to get a big old streak of light behind him like he's burning up. Yeah, see that? And they'll start breaking apart into little bitty pieces as they burn up in little bitty pieces. That's why later on here we see, get back to that, a whole bunch of little bitty pieces as they break apart and burn up. It's got to be the satellites. That's pretty cool. It's so blue this time. It seems to. I'm just curious what the heat shield looked like. It was very hard to tell from this view. The sides look fine. Like none of this stuff looks bad. We didn't see any burn through on the flaps here, so that was good because we saw that every single time before. But there's just not a long enough view when it's flipping and we get like this view. It's not a good view yet of, you can see it, but it's just not clear. You can't really tell what you're looking at. The best view we get is when they get the drone back looking down on it. This guy. It's just hard to tell what we're looking at here. Like there's no way that all these different discolored dots down the middle, they're all missing. There's no way that's true. So it's just like some of them are colored differently. I don't know. I don't know what to think of this. It's not orange because there's no metal, but I think the white might be the crunch wrap stuff burning off, and that's okay if that happens, but it does question the reusability of it. If that's burning away, how long does it last until you have to reapply it? Or can you just like squirt it in between them again? I don't know. I don't know. I think the one tile they did leave exposed was maybe here? Maybe that tile? I don't know. Boom. That's that right there. That's got to be a COPV, a compressor overwrap pressure vessel. So it's I don't know what the metal is on the inside, but then it's a carbon overwrap of that, where they have high pressure like nitrogen and things like that in there. That's one of those flying. That's got to be. It's all that could be. It's on fire and it's spinning and it's long and slender. And it came from up here, like where the payload bay was. So that makes sense. That would fly out of there. Well, new reef to be made. Glad they showed the boom this time. Okay, well, I think that's going to do it. I think we saw some impressive shots. Let's go back to the cool ones that, not him. Like these views of the blue marble. Sun setting back that way. Cool. Alrighty, well, thank you all for joining and watching a rocket launch with me. So we will see you on the next one, maybe tomorrow, maybe Monday, Tuesday. I don't know. I don't know what I'm going to do. We streamed a few extra days this week for this kind of stuff, so we'll see. Anyway, thanks for hanging out, and we will see you next time. Bye.